Okay. Good morning, everybody. Welcome
Morning,
to
sir.
welcome to the new year of mathematics the easy way. Last year was like an experimental year for this modality. We were online. In the past used to be exclusively in the classroom. And one of the things that I did last year was to sort of stay off camera, because I said I wanted the students to focus on the mathematics, right? But I felt like at the end of it, there was a kind of disconnect between myself and the students. And I really believe that I get much more out of the students when, I'm connected to the students, so that they can live with me and talk to me and interact a lot more and, have confidence to let me know when they're having issues so we can sort out those issues. So I'm starting today's session by, bringing myself on camera, right? But once we start the lesson, I'm gonna pause the camera so we can focus on the maths. But each time we have a discussion and we start to talk, I'm gonna go in camera. I also would like you guys to turn on the cameras so we can know who is who and just have a connection, even if it is not for the entire session. For example, when you speak, I prefer that you turn on the camera. Um, you know, we plan to have some face-to-face sessions where I have some persons in Trinidad, in Tobago actually, so they won't be able to attend the physical face-to-face, but still, we'll find a way to incorporate them in those sessions. And I want to have multiple one-on-one sessions. All right, so somebody's saying that they're sick. Well, the session is recorded, right? The session is recorded, so therefore, if for any reason you can't come to the session or you miss a class, the sessions are recorded, and I try to keep the sessions online and available for a week or two, and so you have that time to watch the video if you miss a class. All right. Also, I actually want the video. I also want the video to be used for revision. So when I put up the videos, I wanted to use it for revision, to look back over what we did. While you do the question, you can go and replay the video. Oftentimes I'll ask you to redo questions that we did in class. In fact, all the time I'll ask you to redo questions. In fact, that is what you're required to do. Each time we do an example of a question or topic, you're required to redo those exact questions first before you go and try other questions. All right, and I repeat that multiple times during the year. All right, so let me talk about the program a little bit now before we get into it. I'm actually doing a topic today, as you can see on the screen. All right, so starting with all guns blazing today. So the class is called Mathematics the Easy Way, because I know that it is really and truly an easy subject. It is like the easiest subject to pass in CSEC. It's just that there are certain things that you have to do in order for the subject to become easy. And it so happens that the main thing that you're supposed to do is the main thing that students tend not to do, which is to practice, practice, and practice. All right. But before we get to the practice, you still have to learn the content, right? So that's why I'm here. I'm here to show you the content of the syllabus, teach you what you need to know, and then give you examples. And sometimes I'll give you examples of a higher level than the exam, such that when you get to the exam, it is easy. Right? I have a strategy that I've been using for many years, and I'm not going to change that strategy because I brought a lot of success over the years. I've had multiple students. I'm getting, well, 100 straight is a commonplace thing in this program. But I've also had students making the top 10 list in their schools, top 10 list in Jamaica, top 10 list in the Caribbean. That's how well the students from this program usually do. And some students come here with a dislike for the subject, and by the time we get to the end of it, they really and truly love the subject, and sometimes even go on to teach friends and family members and so forth. So this really is a fun subject, and we want this to be a fun session, and I want everybody to participate. Right. So if there's something that you don't understand, you must be free to say it. If there's any other class that you you might hesitate to ask a question, this is not the class. You ask the questions here. All right, because I'm a very patient person when it comes to the lesson. And sometimes I might sound a little bit intense, but I don't want it to take it personal. Sometimes as a teacher, you have to get a little bit intense for the information to stick with the student, but it's nothing personal. All right. At the end of the day, I want you all to do extremely well, and extremely well for me is 1 straight A's. And that's what we aim for in this class, regardless of your standard now. That's what we aim for. Some persons in the class are, at a good level, because they might be in a good program and have a good background in maths, and they will learn the content a little bit easier, a little bit faster. Some persons not so much, because the background might not be so strong, but it doesn't matter. So some persons will require less work to get up to the A standard, and some persons will require more work to get up to the A standard. So once I discover the persons who need more work, I'm going to give you that more work. And the persons who are, at a very good standard, I give you more of a higher work. And that's why the one-on-one session is so important, and that's why it is so important as well for me to get to know you, each of you individually. And so that is another reason why we have to communicate. We have to communicate for me to understand each person. All right. All right. So how the program is set out is that, so we're doing the entire syllabus in 1 year. So I'm teaching you everything that you need to know. So we do it topic by topic. All right. And we tend to do the section 2 topics of the syllabus first. Because the section 2 topics of the syllabus are the most certain topics that you get on an exam paper. So I want to cover those first. All right. In order for us to get some of the section 2 topics, we have to do some section 1 topics, and that is how we end up covering some of the section 1 topics, because they are prerequisites for some of the section 2 topics. So for example, in order for us to do transformation, which is now in section 1, but used to be a section 2 topic primarily, and also still comes in section 2. In order for us to do transformation, we have to learn matrices first. Also, in order for us to do vectors, again, we have to learn some matrices first. In order for us to do a topic which is section 2, linear programming, we have to learn coordinate geometry, and it will be good if we also learn functions. Functions and coordinate geometry are section 1 topics, although you can still get some functions in section 2. Right, so there are some topics in section 2 that we'll be doing. For example, trigonometry. So trigonometry will have some higher level trigonometry in section 2 and some lower level trigonometry in section 1. So in order for us to get to the higher level trigonometry in section 2, we have to learn the lower level trigonometry that you will see in section 1. All right, but the aim primarily is to cover the section 2 topics first. So like topics like fractions and consumer arithmetic and sets and these things, we won't be touching those topics directly until close to the exam. So for example, you see quadratics on the screen. The level of the quadratics that we are doing today will be such that you can approach the quadratics that you see in section 2 of the exam paper. All right. And that is how we proceed shortly here. So that is it in a nutshell. We try to finish the syllabus by March, assuming that the exam is in May, June. And then we use the period between March and the exam for what we call exam preparation. So between now and March, we are learning the topics. All right, we're learning the topics. In some cases, you won't master the thing as yet, but we usually blossom at a much greater rate from March down to the exam, because then we are doing all the topics simultaneously, and we are doing exam level work, and we are learning exam strategy, and we are learning time management, which is very, very important. A lot of persons go in exam and they know the content, but they have difficulty in the exam, and they don't end up doing their best because they don't manage the time properly. Right, so we practice a lot of time management when we get to that stage. Some persons will have SBAs to do. Some students will be doing exam privately with me, so I'll supervise a SBA for them. Some students doing SBAs in the school, I can still give you some assistance where that is concerned. But generally speaking, I tend to leave the SBAs for the school teacher, because you have to satisfy what the school teacher wants. All right, for the SBA. And that is it in a nutshell. All right, so you can just call me sir. My name is Rafik Shaw, as you know, and I'm a 24-hour teacher, meaning, you know, we're in a WhatsApp group. You have my WhatsApp number. You can send me messages and questions and anything at any time of the day. All right, if I don't respond right away, it means that I may be busy. I respond when I can. All right, so you can send me questions at any time. Yeah, man, that's okay. I know some persons coming in late, and I know some persons at the vaccination site today. But the class is recorded, and so those who come in late, you can always watch the recording. But we have not started as yet. All right, anybody have any question I don't want to ask before we push on? Anybody? All right. So everybody ready for the content?
Yes, sir.
So you guys not gonna turn on your cameras. Let me see you. I'll wait for another time. You think you're kind of too shy today? I don't want to pressure the camera thing too much, you know. I want to wait another time. You get more comfortable. All right. All right, I'll take that as a yes. Nobody's answer. Well, Brandon, yes, happy to see you, sir. So that is Brandon, who just came on screen. All right, so I have a little cough, guys. It's something and swallow something dry earlier today, so I have a little cough. So bear with me a little bit. All right, so I'm just gonna go straight into the content, guys. All right, so I'm gonna come off camera now, and we're gonna jump straight into it. All right. All right, so on the screen, you see the topic, quadratics. And at the end of today's class, we should be able to do at least one exam level quadratics question. All right. So this quadratics topic is going to take us maybe 2-3 weeks to complete, because there are various sections in it. All right. But the first part that we want to cover today, we should be able to do a question. But tomorrow's class, you all know you have class again tomorrow. But tomorrow's class is going to be mainly about practicing questions from the topic, from what we're doing today. And then the class on Wednesday, because we all because we're all going online, we don't have face-to-face allowance as yet. I'll let you know as the week progress if we be able to have face-to-face, because we have to basically go by what the school says. All right. So if we're not gonna have face-to-face, then I might just bring everybody online on Wednesday or Thursday, whichever day is more suitable. I think maybe it should be Wednesday. Right. And that class is really about you now demonstrating what you have learned, so we can clarify any little thing that we need to clarify. Anything that you don't understand, we can clarify. That's what the one-on-one session is about. But I find some way of doing it, even in the online in modality here. All right. So what is quadratics? Quadratics refer to mathematical representation in which the highest order of the variable term is x. The highest order is 2, meaning an x squared term is included, a squared term is included, and it is the highest power in the expression. All right, I'm going to give an example just now. So what's a variable? A variable is a quantity that can take different values. You can give a variable different values, all right, several different values. And a constant, as it says, a constant doesn't change. So what you're seeing here on the screen, ax squared plus bx plus c, this thing down here, right? That's the expression. That's a standard form for a quadratic expression, right? That's a standard form. And we have to be able to identify the a, the b, and the c in the expression. All right, now the quadratics is just like the second level of the polynomial system. Now, what's a polynomial system? Polynomial system is a series of powers of x values, and you're adding them. It's a series, meaning you're adding the values. So if I were to just write out the polynomial system and give you so you can, get an example. The first one is ax plus b. That's the first order, because the power of the x here is 1, and that is called a linear. This is a linear. And then the second one is the quadratics. It becomes ax squared plus bx plus c. That's the second level, second order. Highest power of the x squared of the term of the x term, which is the variable. These are the variable values. The variable term, the x squared and x. The highest power is 2. That's called a quadratic. Don't mind my spelling, quadratic. Don't mind my spelling. And then the next one will be the cubic, and it will be now ax cubed plus bx squared plus cx plus d. And students who are doing add maths and pure maths have to learn about this one. For CSEC, we're doing these two, linear and quadratic. But today we're focusing on quadratic. We're eventually going to learn linear, about lines, equations of lines and stuff. We're starting with something higher, which is quadratics, which is this one. This is called a cubic. It's a cubic expression. Cubic in the polynomial. Highest power is 3, x cubed. Then naturally, the next one will be x to the 4th. So it will be ax to the 4th plus bx cubed plus cx squared plus dx plus a, b, c, d, e. This one is called a quartic. Highest power is 4. It's called a quartic. Quartic. And it goes all the way down to any order. We can get x to the 5th, x to the 6th, x to the 7th, and so on. You're not going to learn about any of these down here in this level at CSEC. CSEC, you're focusing on this up here, the linear and the quadratic. We're on the quadratic now. The A, the B, and the C are numbers, are values. So for example, if I were to write an example of a quadratic expression with the values, it will be maybe something like 2x squared minus 3x plus 5. Notice I put a minus here because the minus 3x is the same as plus negative 3. Same as plus negative 3. All right, so this is a quadratic. And what it is that these have some similarities and they also have some differences. All of these polynomials, and there are certain things that you can do with the polynomials. And you will, when you do add maths and pure maths, you'll learn a lot more of the things that you can do with these polynomials. All right, there are descending powers of x of different order. The linear is the first order, the quadratic is the second order, cubic is the third order, quartic is the fourth order, and so on and so on. All right, I don't write out anymore because even at the pure maths level, they tend not to go higher than this one. They tend not to go higher than here, even at pure maths. All right, so we are at the second order, which is the quadratic. And if you notice, this is called a quadratic expression because it's an expression with no equal sign. It's just an expression there. And there are a number of things that we can do with the expression. All right, so let's continue. So let's continue. So far, so good, guys. But okay, so good. So far, but good so far.
Yes, sir.
Yes, sir.
All right. Remember, and if you don't understand something, let me know right away. And we're starting from the very basics, you know, guys. So some persons will be familiar with these things already. Just understand that we have to start from the very basics, so that persons who have never done this before can be brought up to speed. I'm not gonna just jump to the top of the tree. I'm gonna start at the root and build it right up. All right. So we'll get the full understanding as we go. All right. So A, the B, and the C are the constants. Right. So for example, if I write 2x squared plus 3x plus 5, the A, this will be the A, this will be the B, this will be the C. Those are your constants. And then now the x is a variable. Why is it called a variable? Because you can give the x different values. And depending on the value that you give to the x, the overall thing will change in value. You get one output value. So each time you give an input value to x, the overall thing will have a different value. All right, that's how it works. So let's continue. So quadratics are very common in maths and is used in solution of many mathematical problems, many real life problems. So for example, when you want to launch a rocket out into space, there are maybe some quadratic expressions and some quadratic equations that they have to solve depending on where in space they want to launch the rocket. You know, when they're putting up buildings and bridges and, you know, and creating instruments, you know, they have to use some quadratic equation to calculate what they're doing. Mathematics is the foundation of the world, really. So everything that you see out there in the world, some mathematics takes place to design the things. In your phone, a lot of mathematics taking place in the phone, and the bridges and the roads, a lot of calculations taking place, and quadratics come into play a lot of the times, right? You know, there are SBAs that we can do to show how quadratics is used in some real life situation. You know, so depending on the SBA that you want to choose, we can maybe look at something like that. But it's very, very common in a real world situation. Cricketers, for example, playing cricket, or a sportsman throwing the javelin at the Olympics. You know, there's some mathematics in there and some quadratics in there as to correct angle and, you know, where the javelin is on a land, and the flight of the javelin, the maximum height reached by the javelin, and the distance that it ends up traveling. You know, can be worked out with quadratics, right? Can be worked out using quadratics. All right, so what are we doing in this course? What are we covering for the CSEC? All right, I'm going to list out the things that you need to know about quadratics, and I'm going to show you the ones that we're doing today. All right, so the first thing there is the first thing that we're doing today. We're going to learn how to complete the square of a quadratic expression. Complete the square. I'm going to explain what I mean by that as we go. But this is a very common thing that they ask in CXC, and it's usually asked in section 2. And there's a reason for completing the square. I'm going to tell you the reason for completing the square. All right, but that's the first thing that's what we'll be doing today, completing the square, and we're going to look at why we need to complete the square. We also have to be able to factorize quadratic expression. We're not doing this week. All right, but we're also going to factorize. We're going to look at the methods of factorizing. All right, and we're going to factorize. I'm going to show you one method in particular. But that won't be done this week. All right, maybe a week after next, we'll do factorizing. Or maybe next week, I'll see. All right, analyzing the properties of a quadratic function. We're going to be doing some of this today. All right, We're going to be doing some of the analyzing today. So we're going to talk about the vertex, which is either a maximum vertex or minimum vertex. A quadratic function tend to have an axis of symmetry. We're going to talk about the axis of symmetry. We're also going to talk about the shape of the graph. So by the end of today's class, we should know why a quadratic graph shape is either a smile or a frown. We're also supposed to understand the vertex and the axis of symmetry. All right. We have to be able to solve quadratic equations to find the roots. Again, we're not doing this week. There are methods of solving quadratic equations to find the roots. I'm going to explain what the roots are. All right, but that's something that we also need to know. I'm going to be doing that as well. Use the quadratic formula to solve quadratic equation. That's a part of 4 and 5 intertwined really. All right, we can solve the quadratic equation using a factorization method, or we can use a quadratic formula method. All right, and the quadratic formula is something, the formula that actually comes on the formula sheet, and I tell you when you absolutely must use a formula. All right, I tell you when you must use a formula. All right, we also have to be able to sketch a quadratic function. We will be able to sketch a quadratic function today. All right, so for example, if we're given this other function, I'm going to put a y in front of it, which makes that function. Without the y, it's just an expression. When I put the y in front of it, it now becomes a function, because when you give x values, this works out to give you y values. So you're getting pairs of x and y values here that can be shown on a graph. I've converted that now to a function. So we're going to look at that today as well. You have to be able to derive the quadratic equation from the roots. We're going to do this maybe 3 weeks from now. Right? So if we know the roots, we can get the equation. Right? And we have to be able to solve, well, this we won't be doing this directly. We're going to be doing this from graph, this one. In the past, in the old syllabus, you have to be able to do it at this level. Now it's really an advanced level topic. But we're still gonna, give you some introduction to it so we can understand it. But it's really from a graphical approach that they wanted to do this. So we're not gonna be touching this yet until we're really at the end of quadratics. The next thing we have to be able to do is solve simultaneous equation leading to a quadratic equation. I'm not talking about 2 lines now. I'm talking about a line and a curve. We're going to talk about that when the time comes. Solving simultaneous equations that give rise to a quadratic equation. That's what we're talking about. So that is like 3 to 4 weeks down the road. We're going to get to this. This topic, is a longish topic. Easy stuff, but just kind of longish. All right. Then, well, this is you're not going to be doing this. You can cross this one out. This really is advanced level work, so you're not going to be doing that. So you can cross that out if you have your handout. You're not going to be doing that. And solving equation reducible to a quadratic equation. This one, not so much. Maybe a little bit, not so much. So you can write not so much for this one. Not so much. All right, it's something that we can do. All right, it's kind of easy. So not so much. I tend to give you the quadratic equation to solve straightforward. Right? This is more like add maths and pure maths level stuff. So we're really focusing on this setup here. All right, and today we're doing this. We're doing this. We're doing the graph. Those are the main ones we're doing today. Those 3. All right, and we'll be able to do an exam question. Couple exam questions, and then tomorrow we're going to practice plenty questions to cement the topic. All right, so let's continue. All right, so far so good, guys. Let me tell you something right off the bat. You're not going to understand everything the first time you see it. All right, that's the nature of mathematics. That's what we have to practice, and all mathematical principles can only be fully understood by solving many questions. You really get to understand the maths when you start to solve the questions. All right, so we introduce it to you and you get the critical information in your brain. But when you start to solve the question, you put all the information together and everything becomes clear. And that's why that's important. That's why doing the class this way, where we're recording the class, that you can go back and watch the video. So after you start to do the questions and you come upon something, you go back and watch me explaining you know, some aspect of it, and you understand it a lot better. But you really get the full understanding by solving questions, right? And come upon the various little challenges and get over the challenges. You have to work questions, right? I'm going to do plenty examples with you. You're required to redo those examples and then also do other examples afterwards. All right. So we spoke about quadratics, and it is very important for us to identify a quadratic when we see it, so that if we get a cubic, we don't try to apply a quadratics method to it. If we get a quartic, we don't try to apply a quadratics method to it. If we get a linear, we don't try to apply a quadratics method to it. So we have to know when an expression is not a quadratic and don't go about trying to use a quadratic method. So for example, if you get a cubic equation to do something with, you can't use a quadratic formula on a cubic equation. You run into problem. It can't work because the quadratic formula is set up for quadratic equations. So the first thing we want to do is identify quadratics. So these are some examples of expressions that are not quadratic. So like this one. That's not a quadratic. Anybody can tell me why this one is not a quadratic? Anybody want to tell me why this one is not a quadratic?
Because
you might and say it. Why?
So because the 3x is cubed and the 2x is squared.
Because you have a cube in there. Remember that for it to be a quadratic, the highest power of the variable has to be a 2. This one goes all the way up to 3. So this is what causes it not to be a quadratic. It's actually not a cubic. So you cannot use any of the quadratics methods on this. So you can, for example, complete the square of this. That's a cubic. You can factorize it maybe and do other stuff, which students at ADMATS will learn. All right. What is that one? That one again is a linear. Linear, right? Good. The highest power of the x is a 1.
1.
Right? Good. Beautiful. Right? So that one is linear. So you cannot use any other quadratics method for this. That is that one. What is that one? Not a quadratic. The highest power is the 4.
Yeah, quartic.
Quartic. You cannot use any other quadratics method to do this one. This one's a quartic. All right, beautiful. So we're going from basics and everything important, guys. Everything important. That one again is another linear. Cannot use any other quadratics method for that one. All right. All right. Let's get into it now, guys. Getting warmer. So we're gonna look now at some of the important things that we have to pay attention to. Everything important. All right. So we're gonna look at some of the things that people ignore that is actually very critically important. All right. So when you have a quadratic expression, right? The rules and the formulae and the methods that we want to learn is dependent on us identifying the various components of the quadratic. All right. So this is what we call a standard form for a quadratic expression. The A right here, the A right there is very important. You're going to see some formulae with A in it. The A is always the number in front, the x squared. We call it the coefficient of the x squared term. If you don't identify the A right, if you don't put on the right value for the A, you're going to get the question wrong, whatever it is that you're doing. The B right here, and now let me put the sign as well. The B right there, the plus B right there, is the coefficient of the x. And the formula that we're going to use and method that we're going to use will refer to the B. The B is always the number in front, the x squared term. And if it has a negative sign, you have to carry the negative sign with it. We're going to see some examples just now. And then the C here with no number and no variable side, it is just a constant term. It's called a constant term. So the constant term in the expression is always called, it's always given the letter C. Now, I want to make a little note right here. A quadratic expression can be written in other forms. Can be written in other forms. It's not me writing like this, guys. It's a pen. All right. I'm bringing in other forms. I'm going to look at the other forms soon. So usually what you do with a quadratic expression, you either factorize it or you can complete the square with it. That's two of the main things that we do with a quadratic expression. It's not an equation, it is not a function. So generally speaking, we just rewrite the quadratic expression in other forms. All right, and the quadratic expression in the standard form gives us some information. We're going to look at some of the information that we get as we go. All right, so let's continue. So I want you can make a note that I just did, guys. Can be written in other forms. That's what we can do with a quadratic expression. Write it in other forms. Let's look at some examples now of some quadratic expressions, and we have to be able to select the A or identify the A, the B, and the C correctly. So is that a quadratic expression? That's the first thing. Is that a quadratic expression?
Yes, sir.
Why is it a quadratic expression?
Because the x squared has a coefficient of 2 and the x has a coefficient of 3.
All right, I hear what you're saying, but let me tell you why it's a quadratic expression. It's a quadratic expression because the highest power of the variable is x. The highest power of the variable is 2. The highest power of the variable is 2. That's why it's a quadratic, because the highest power of the variable is 2. It's a squared term. Highest power is a squared power. That's why it's a quadratic. Then now we want to identify the A, the B, and the C. So tell me, what is the value of A in this expression? A equals 2. Okay, I wrote it off for you.
2.
Good. What's the value of the B? What's the B?
3.
3. What is C?
4.
Nope.
Negative
C is
4.
negative.
Negative 4 is 7.
Beautiful. You have to always look at the sign in front of the number. Always look at the sign in front of the value. So the plus C is negative 4. That's what it is really, you know. If you're comparing this expression and this expression, the plus C is negative 4. See, the plus C is really negative 4. And when you have plus C, you don't need a plus in front of it. So you can just write the C is negative 4. All right, and that's how it goes. C is negative 4. All right. So generally speaking, we can just identify like that. All right, good. So the C is negative 4. Let me erase some of this as well. I'm taking my time with it today now, guys. So we're just starting, right? So let's continue. So the C is negative 4. Let's look at another example. Is that a quadratic? Is that a quadratic expression?
Yes, sir.
Yes, sir.
Good.
Yes, sir.
A quadratic expression, the variable term is x, and the highest power of that variable term is a square.
Square.
Good. What's the value of A? What is A?
Sir, negative 1.
Negative.
Negative 1, sir.
Negative 1, sir.
Negative 1. Good. So when there's no number in front of the letter, then the coefficient is 1. So for example, if I just write down x right here, so then that is 1x. So the coefficient of the x there is 1. Understand? That's how it is. If I write down b, no, let's not use b. I'm using a coefficient. The variable. Let's not say b. If I write down r, there's only one r on the screen there. So the coefficient of r is 1. Right? So when you see a letter, the coefficient is 1. And just because there's a minus in front of this one now, so what it means is that we can basically put a 1 right here, minus 1x squared. So the A is really negative 1. Negative 1. And remember, the A, the B, and the C cannot be expressed with the x term in it. Can't be anything with x. Has to be just a number. The A, the B, and the C can only be just a value, a number, not a variable. So you cannot write it in terms of x. All right. So everybody agree that the A is negative 1, right?
Yes, sir.
Yes, sir.
Good. Good. The A is negative 1. So what is the B? What's the value of B?
Sir, 0.
Good. There's no
0,
x value
sir.
there. Good. There's no x value there. 0 x value is there. So the coefficient of x is 0. The coefficient of x is 0, so the B is 0. And what is the C?
7.
C is 7. C
Seven,
is
sir.
positive 7. Remember, I know we're doing these questions, guys. If you don't select the A, the B, and the C correctly, you're gonna get what you're doing wrong. That's the first thing we have to be able to do. Correctly select the A, the B, and the C. We're gonna see that later. It becomes very important. Everything important. Let's look at another example. Negative 3x squared minus 5x. Is that a quadratic expression?
Yes, sir.
But I agree with that. I'm not hearing from some other
Yes,
person.
sir.
You know,
Yes.
usually the girls talk more in the class. Oh, not so quiet today. Huh? Want to hear from everybody, Come here to break out our shell in this class. If there's any other class you can't talk in, when sir asks a question, this is the one that you can talk in. All right? I remember now, I cannot be watching the chat. So you need to just say it to me, please. Right? I can't be watching the chat because I'm seeing what you are seeing on the screen. I'm not seeing the chat. I can only see the chat if I stop and look at something else. So you need to speak up, please. And if your mic not working, try and get your mic fixed. So you need to talk up in class. All right. So it's a quadratic because the highest power of the variable term is a square again. All right, it's 2. Highest power is 2. The variable is x. What's the value of A in this one?
Negative 3.
Negative 3, sir.
Beautiful. What is B?
Negative 5.
Negative 5.
Beautiful.
0.
Negative 5. And C is 0. There's no constant term there. So the C is 0. Lovely. Let's look at another one. Is that a quadratic?
Yes.
Yes, sir.
That's a quadratic. Beautiful. Because the highest power of the variable term is a square. What's the value of A?
Sir, positive 7.
6. Positive 6.
6.
Who says 6?
Positive 7, sir.
Somebody says 7. If somebody says 6. Who's correct? 6 or the 7 is the A. Which one? There's only two of them there.
7.
All right. So it has to be the 7, guys, because remember, the A is the coefficient of the x squared term. It doesn't matter where the x squared term appears in the expression. That's the x squared term. The number in front of the x squared term is the A. All right, because I can take this expression and I can rewrite it as 7. I can rewrite it as where am I? I can rewrite. Oh Lord, what did I do? Yeah, my guys, I haven't done this in a while. Right, I can take this and I can rewrite it as 7x squared plus 6x. It's the same thing. 7x squared plus 6x. So you see, that's an A. All right. So it doesn't matter where the x squared term is in the expression. Doesn't matter. The number in front of the x squared is your A. And you have to learn that because CXC will give you a question, but they don't put it in the standard form. The standard form, is when the x squared term comes first, the x term comes second, and the constant term comes third. But they don't almost give it the values in that order. They can switch around the order of the values, but the A, the B, and the C are chosen the same way. The coefficient of the x squared is 8. All right. So in this case, the A is 7 and the B is 6. So the A is not the first value in the expression. No. The A is the number in front of the x squared. The B is not the second value in the expression. No. The B is the number in front of the x. And the C is not the third value in the expression. No. The C is just the constant term, and they can rearrange the value sometimes. They don't have to give it in the standard form all the time. All right? So that's a quadratic expression, guys. So let's continue. C is 0. All right, so now we're going to look at a quadratic function. What's a quadratic function? A quadratic function is basically now when you have another variable involved. So instead of f of x right here, I could have instead say y equals ax squared plus bx plus c. A quadratic function is when now a second variable is being calculated. I see the equal sign there. And a quadratic function, let's write it, can be drawn on a graph. I'm actually going to draw one just now. You can draw it on a graph because you have x and y values that you can plot on a graph. So a quadratic function can be shown on a graph or drawn on a graph. So it's not just the expression you have anymore. So now when you give x values, you work it out, you work out the right side, and it tells you what the y values are. We're going to see an example just now. But guess what the beauty about this now? You choose the A, the B, and the C in the exact same way as you did with the expression. All right, so I'm going to run through this one quickly then. Bam, that's an example of a quadratic function. What is the value of A? Quick and fast.
Positive 3.
Positive 3.
3, sir.
What is B?
5.
5.
5. What is
Positive
C?
Negative
Negative
2.
2.
Beautiful. C is negative 2. Next example. Is that a quadratic function?
Yes,
Is
sir.
that a quadratic function?
Yes,
Yes,
sir.
a quadratic
Yes, sir.
function.
Yes, sir.
Yes, the second variable there. So when you give x values, work out what the x values are on the right side, you get a y value. So for each x value, you get a y value. So it's called a function because you're getting an output value. The x values will be your input values, and you work it out and you get an output value. So a function is when you get an output value after you put in an input value, like our function calculator works. You put in values in the calculator, like you add up some values and subtract and multiply some values in a calculator, and then you press equal, it gives you an output value. That's a function calculator. Function is something that you put some input values in and get the output value. All right, so that's a function. It can be drawn on a graph. All right, so for this one, what's the value of A? What's the value
1,
of A?
sir.
7.
Negative 1.
Negative 1.
1, negative 1, negative 1.
Never leave your sign behind. Make the mistake. I don't have a problem with people saying the wrong thing now, you know. Because you're making the mistakes and learning from it. And that's why I like when people talk and say the mistake. So when you talk and say the mistake, you learn from it. Making mistakes is very good. Make all the mistakes from now. So that way you don't carry the mistakes in the exam with you. That's why we have to practice. We practice so that we can make the mistakes now, learn from them, and leave them outside the exam. We don't want to carry them in the exam. So practice out all of the mistakes that you can possibly make. So say out the mistakes as well. So the A actually is negative 1. So remember, when there's no number in front of the variable, it is a 1. But they're not going to show the 1 because it does not look good to show the 1. To put a 1 right here, so it don't really make sense to put a 1 right here. So generally speaking, you don't put 1 when the coefficient is 1. All right. So that is just as simple as that. So the A is negative 1. What's the B? What's the B, guys?
2.
The B is 2. The B is 2. And same thing again, you know. So when something is positive, you don't tend to put the positive. It's understood to be positive. So the B really is a positive 2, but you leave out the positive. You know, say it's positive if you just write the 2. All right, but when something negative, you have to put the negative. That's just so it goes. That's just the standard way of doing the maths and showing the maths. Now, what is the C?
7.
The C is
7.
Beautiful, beautiful. Your female voice now jumping in, nice. Everybody chime in as you go, you know. Get comfortable. There's one class must get comfortable in is this one. All right. Is that a function? Is that a quadratic function?
Yes, sir.
Yes, sir.
Yes, it is. All right. You see this G of X right here, so? Can be written as well. That's another way of writing Y, as I did up here. That's another way of writing Y. That's another way of expressing. This means a function of X. G is a function of X. This one right here, so F is a function of X. I'm going to do functions at that topic. I'm going to see more of these and more of these. But just like Y, just like Y. No, they don't operate any differently from Y. All right, so don't make the G of X tricky. All right, so this X really is not really a variable X. It's just saying, for example, G of 1, for example, means that this becomes equal to 4 times 1 squared minus 1. That's all it means, you know. And this will work out to 3. This will work out to 3. So G of 1 will be equal to 3. So G of 1 will be equal to 3 because it works this out to 3. All right, but it's just like say Y equals 3. It really does the same. Not different, not really different. All right, so let's go. So, bam, the A equal 4. Everybody can agree with that. What's the B? What's the value of B?
0.
0,
Zero,
sir.
sir.
0. What's the C? Let's tell me the C one time.
Negative
Negative
1.
1.
All right, you guys getting bright. Brilliant. Lovely. Everything important to know. And you have to get this part right before you can get the rest of it right. All right. Is there another example? One more example. One more example on the screen there. Let's see. Talk to me now. That's a quadratic, yes? H of
Yes.
X.
Yes, sir.
Yeah. What's the value of A right here?
Negative 4.
Beautiful. Negative 4. Beautiful.
Negative
What
4.
is the B?
3.
What is the
3.
B? And what is the C?
0.
0.
Beautiful. All right. So we'll get this part right. We're almost ready to move on to the next part now, you know. But let's look at some other things that you can have with the quadratics. You can also have what we call now a quadratic equation. Quadratic equation. You know what is that? You know what an equation is? An equation is something that can be solved. You know why this can be solved? Because it only have one unknown in it. It has one unknown. So for example, if I write this, look at it, look over here so now on the right side. If I write 2x squared plus 3x minus 5 equals 0, this is an equation because it can be solved. And how I know it can be solved? Because it has one variable, one unknown. Any equation with only one unknown can be solved for that unknown. All right? And that's why this is a quadratic equation. So the quadratic equations now, let's write it up here. Let's write it up here. The quadratic equations, we say, can be solved. You solve it, means you find the value of x. When you solve an equation, you're finding the unknown. So it can be solved. And this one now, to find, taking a little bit further. When I say this again later, but I'm taking a little bit further. It can be solved. And when you solve a quadratic equation, you're finding the roots. It can be solved to find the roots. You know what I call the roots? The roots are the x values. For example, now the roots are the x values in this equation over here. The roots will be the values of x that will make this expression be equal to that 0. Those are called the roots. And it can also be represented on a graph. I'm going to look at those later. But for now, when you solve an equation, the answer that you get is a root. If it's only one answer you get. If you get two roots. If it's three roots. Let me show you something now, quick and fast before we go on. A linear equation, like for example, 2x plus 4 equals 0. Linear gives you one root. For the highest power of the x is 1. One root. If I have 2x squared minus 3x plus 5 equals 0. When I solve that, I'm going to get 2 roots. For the highest power is 2. I'm going to get 2 roots. If I solve a cubic, 5x cubed minus 2x squared plus 7x minus 8 equals 0. That's an equation again, but the cubic for the highest power of the cube of the variable is 3. When I solve this one, cubic, I'm going to get 3 roots. So this one give me 2 roots. This one down here is going to give me 3 roots. And this one up here is only going to give me 1 root. One answer. It's called a root. So the value that you get when you solve an equation is called the root. It is a value that satisfies the equation. And a linear equation gives 1 root, a quadratic equation gives you 2 roots, and a cubic equation gives you 3 roots, and a quartic equation gives you 4, and a quintic, which is x to the 5th power, gives you 5, and so on. That's how they work. And then at advanced level, we learn about the nature of the roots. So the roots can be real and different, real and equal, and so forth. We're not getting into that now. So when we solve the quadratic equations, we're gonna be expecting to get 2 roots. And when we do a couple of weeks, when we do solving the quadratic equation, we're gonna look at the nature of the roots, how the roots can be, and what causes them to be how they are. But for now, we just know that we can solve a quadratic equation and find the roots, the values of x the values of x that solve the equation. Now, this thing right here is very important now, guys. Everything important. When I said the expression is equal to 0, we want it to be equal to 0. So before we identify the A, the B, and the C, we must make sure that the expression is equal to 0. Why is that so important? That is important because the rules and the methods and the formulae or the formula that we're going to use to solve a quadratic equation is based on it being in this standard form with the expression equals 0. So you must always put it in that standard form before you try to solve it. So for example, if I give you, look over the right side now. If I give you, for example, I just go ahead of myself, 2x squared plus 3x minus 5 equals 1. This is not a standard form quadratic equation because it equals 1. Don't try to solve this. This is called a basic form. This is in a basic form because it have a 1 over there. We need to have 0 over there for it to be standard. 0 is what we want. And right now is a 1. So that's a basic. And we don't solve basic. Remember, don't solve basic. Always solve standard. So anything they give you, any rule that they give you, any formula that they learn, you always have to put the thing that you're solving in the standard form first. Don't try to solve it in a basic form. What makes the quadratic equation standard is when your expression is equal to 0. Now, yes?
Sir, what do we do when we come across a basic form, sir?
You transpose it into a standard form. Very good question. So for example, this now take the 1 over here. This one I'll just take the 1 over here and subtract it. So this now will become 2x squared plus 3x minus 6 equals 0. So I'm going to get the minus 6. So
Yes,
the minus 6 from this. Because when this one goes over here, it becomes minus 1. Minus 5 and minus 1 becomes minus 6. All right? So you would now solve this one. This one is now standard. Standard. Good question. So you solve this one. Now, these two equations are the same, really, you know. It's just that this one is in a basic form, this one is in a standard form. So you solve this one, work with this guy down here. So remember, it's always important to put expression equals 0 first. And CXC test that all the time, you know. We then put all the 1 right here. Some people run guys a quadratic formula and put the A equal 2, B equal 3, C equal -5. Wrong. C is not equal to -5 because it is not in a standard form. You can only identify the A, B, and C correctly when it is in the standard form first. So you put in the standard form first before you try to solve it. Down here now, we're solving this. We know so the A equals 2, the B equals 3, and the C equals -6. If you use -5 up here, you're dead. Dead, dead, dead. Wrong answer you're gonna get. Because the C is actually -6. You want to get the correct answer. All right, so we'll spend some time on that. We're gonna say that
what
all
is
those
the
things.
highest number they put for the basic form?
Huh? They can put it anywhere, man. They will all, it can be any way. We're gonna see some examples just now. It can be any way. They don't have to put only a number here. They could have put some with x over here as a 2. So instead of 1, they could have put 2x over here as a 2. Instead of over the 2x and subtract it from that one. And leave 0 over there. So it's not only numbers alone you can put on over there. You understand?
Yes,
You understand that? Good.
Yes, sir.
All you know, you have to transpose away everything and leave 0 over here. So transpose everything away and leave 0 alone over there. And then you put the
Yes,
A. Yes?
For the 2x, you subtract from the 3x, sir.
Yes, you subtract it. If it was 2x, you subtract from this and get x alone. We just write it out since you asked the question. So we have 2x squared plus 3x minus 5. We say if it was equal to 2x, carry it away and subtract it from that one there. And then now this is basic, so we don't solve this. That is basic. We don't solve basic. That's your basic. And we throw over this and subtract from the 3x. It will become 2x squared plus 1x, which is x minus 5 equals 0. This now is the standard. Solve the standard one. These two are the same equation, and we'll just transpose it into a standard form. Then you solve the standard. And when it is in the standard form, now you're able to identify the a equals 2, the b equals 1, and the c equals -5. And use these values now for your solution. Okay, you're going to be using those values for your solution. All right, so let's continue to identify the A, the B, and the C correctly. But good, I like those questions. And I know that a lot of persons got help from those questions. I like it a lot. Beautiful. All right. So, everybody good so far? But okay?
Yes, sir.
All right,
Yes,
so
sir.
let's continue. Let's continue down now. Let's continue down. So, that's a quadratic equation. What's the A value? It's standard, right? It is standard, so we can identify the A, the B, and the C. First thing we have to look and make sure that it's standard, guys. Very important. Equals 0 means that it is standard. So once we know it is standard, then we know we can solve it and we can identify the A, the B, and the C. Talk to me now. What's the A? What's the value of A?
3.
Three.
What's the value of B? What's the value of B?
-2.
And what's the value of C?
Positive.
4.
Beautiful. All right. So we get those values good. We drop them in the quadratic formula, we solve it. All right. Next example. Is that a quadratic equation?
Yes, sir.
Is it standard?
Yes, sir.
Yes, sir.
Kind of standardish. You don't really want the x squared term to be written first, don't it? But no matter, it's still kind of standard. We really make it standard this time because you have the 0. You have the 0, and you are able to correctly identify the A, the B, and the C. So yes, it is standard. Even though you don't really set out in a nice descending order here. Descending order means that the power of x going down from 2 down to 1 down to 0. Right? So it's not really descending like that, but no matter. You are able to correctly identify the A, the B, and the C. So yes, it is standard because you can do that and because they also have the equals 0. So talk to me then. What is the A?
-2.
-2.
Beautiful, beautiful. What is the B?
6.
6.
And C will be -5.
Positive 6.
-5. So the A is -2, the B is 6, and the C is -5. Beautiful. But understand that? Everybody go to that?
Yes, sir.
All right. All right. Everything important, guys.
Yes,
Next
sir.
example. See one there now. Is that a quadratic equation? Is it a quadratic equation?
No, sir.
Huh?
It's not in the standard.
Yes, sir. Yes, sir. Yes, sir.
It
It's
is
not
a
in the
quadratic
standard form,
equation.
but it is a quadratic equation.
Yes, so it's basic. It's basically a quadratic equation. It's a basic quadratic equation. A quadratic equation in a basic form. And all you know is a quadratic equation, really, because it can be transposed
the
into
power
a
of
standard form. Huh? Because the x squared term is in it, and it's also the equal sign in it. So it can be transposed into a standard form. It's not an expression, you know. It's not an expression because the equal is there. And it's also not a function. Oh no, it's not a function. Oh no, it's not a function. Because there is no second variable in it. There's only one variable in it. See that? So that's what causes it not to be a function. It's not a function. If they would have a y plus here, so y plus, it will be a function because it means we can transpose this over here, so and get y equals something, something, something. So it will be a function. You don't solve function. You don't solve equations. You draw graphs with functions. You don't solve functions. You solve equations. All right? So that's an equation. It's just that it's basic right now. We don't solve basic. So if you're in the exam and give you this to solve, you say, you're gonna trick me, you know? You transpose that first, put it in the standard form first, and let me tell you something now, everything important. When you're doing your quadratics, anything in quadratics, it's always easier when the x squared term is positive. I'm not going to tell you that you must not get comfortable when the x squared term is negative enough. But the things that you do with quadratics, factorizing and this and that, it just happens to be a little bit easier, make less mistakes, less complicated a little bit when the x squared term is positive. So if I'm going to transpose this basic into a standard, I'm going to transpose it in a way to make the x squared term positive. So let me do it over here and show you what I would do and show you what the other way would be, and it will still be correct. So watch this now. I have 7x equals 3 minus 5x squared. Same x squared term there. I want it to become positive. I'm going to take it and put it on this side, and it will become positive 5x squared. And then I don't want anything over this side. I'm going to take the 3 again and move it over here and subtract it. So when I do those two moves, I'm going to get 5x squared plus 7x. The 7x that was originally there is now here. And the 3 comes over and become negative 3 and now equals 0. But understand that? You guys understand that? It's the same equation,
Yes, sir.
but I've transposed it into standard. And now that I have it in standard because of the equals 0, I can now correctly identify that the A is 5, the B is 7, and the C is negative 3. And that's good. Now you could have decided instead to transpose this over here, like so. Watch this now. 7x equals 3 minus 5x squared. I could have instead decided to bring this over here and leave 0 there. Watch this now. All right, if I take this and transpose this over this side, I would have 0 equal, I'm going to put it in a standard form now. All right, let's do it like this. 3 minus 5x squared minus 7x.
So, sir, it's a particular way that you want us to do it, or we can do it either way.
Say again?
Sir, we can do it either way, or you want us to do it
Either way.
specific
I can do either way. I can do either way. If I'm doing it like this, then it says that this equals 0, can as well come here, so too, don't it? Same thing, don't it? I'll move this. Same thing. Agreed? But agree with that?
Yes, sir.
Yes, sir.
Same thing.
Yes, sir.
So if we do it like this, what would happen is that the A will be negative 5, the B will be negative 7, and the C will be 3. But guess what? When you solve this, or you solve this one, with this A, B, and C, and this A, B, and C, I'm going to give you the same answer. Doesn't matter. Just that I would prefer you to do it this way up here. I would still prefer this one, because I tend to make less mistakes when the x squared term is positive. Right? But whether I do it this way up here or do it down here, I'm going to get the same answer in the end when you solve it. All right, so let's see what method we use on the slide. On the slide, we'll do it that way, okay? Which is the way I prefer up here. That's what we did. See it? And then once you do it that way, you have the A, the B, and the C. All right, let's look at this other example. Going from basic to standard. Let's look at this other example. That again is a basic quadratic equation, don't it? Basic. See it? Basic. Again, this one down here that I'm looking at now. It's a quadratic equation again, you know, but it's basic. It's in a basic form. So I have 3x minus 2 equals x squared minus 7x. It's an x squared term here, so it's positive. I want to leave it positive, so I'm not going to move it. I want to take these 2 and transpose them over here. All right, so when I carry over the 3x, it's going to become negative 3x. And when I carry over the 2, it's going to become positive 2. Let me go step by step. I'm going to have 0 left over here. X squared is this one, x squared. I have negative 7x. Carry over this 3x over here, become negative 3x. Negative 3x. And take this negative 2 and bring it over here, it becomes positive 2. Positive 2. So my expression equals 0. What I can do, I can consolidate these two x terms. Negative 7x and negative 3x is negative 10x. Negative 7 and negative 3 is negative 10. So 0 will be x squared minus 10x plus 2 So when I have 0 on this side, equal, I can as well put this equal 0. So I can instead write x squared minus 10x plus 2 equals 0. Same as that, really. All right, I just put the equal 0 over on that side instead. Make it look more standard. Make it look more standard. Then I'm going over A, B, B, and C. The A equal 1, the B equal negative 10, C equals 2. But I go to that. This up here so was basic. That's basic. That's where that we don't work with basic. We convert it down here to standard. That's where this work with that. Standard. Don't solve basic. Always solve standard. But I go to that.
Yes, sir.
Are you okay?
Yes, sir.
All right.
Yes, sir.
All right.
Yes,
So
sir.
still building up in a guy. Still warming up, When it start get hot yet, Still just bubbling a little bit, right? When I get anywhere, we're going from the very basics, everything important. All right, every single thing important. Because if you get this part of it wrong, you're gonna get the rest of it wrong. So I have to get the basic parts right first. All right, the simplest parts, I have to get them right first. Sometimes we focus too much on the top end of the maths, and we really need to solidify the bottom end first. All right, so we want to go to the full gamut of the thing. All right.
Excuse me, sir.
Yes.
What would happen if it was 3x minus y instead?
If it was 3x minus y right here, then
Yes, sir.
It wouldn't be an equation, to be a function.
Okay, sir.
3x minus y equals x squared minus 7x. That would be a function. That's not an equation. You can't solve a function. It have two unknowns in it. You can't have two unknowns in one thing and solve it.
Thank you, sir.
Good. That would be a function because you have another variable in there. All right. That's that. Let's continue. Quadratic inequalities, it's just basically when the quadratic have an inequality in it. So we're not going to spend a lot of time on this, right? Because it's not on the syllabus so much anymore. We'll get to it later on. We're going to do the topic of inequalities by itself. So I'm just going to run through this part. So basically when a quadratic is when an inequality sign. Right here says one of the inequality signs. What are the inequality signs? Greater than, less than, greater than or equal. I'm write them side by side instead. So this sign right here is either a greater than sign, a less than sign, a greater than or equal to sign, or a less than or equal to sign. Then it becomes a quadratic inequality. And there are specific methods to solve these quadratic inequalities, but it's not on the syllabus anymore. So this is an example of a quadratic inequality. See, instead of an equal there, we have a greater than sign. All right? We still identify the A, the B, and the C the same way. A, the B, and the C are identified in the exact same way. So that's it. Let's run through this one. Another example is that A, the B, and the C are identified the exact same way again. I suppose it like that. Rearrange it. Not really transposing, we'll set them out differently. Not really transpose it. We'll just switch on the values in the standard form. One also is a quadratic inequality, can be transposed into the standard form to get the A, the B, and the C again. You want to have the 0 on the right side. Bam. See there? So the A equals 5, the B equals 7, the C equals -3 again. That's another example. That's that one that we had for the equation. That's not inequality. Transpose again the same way. A equals -1, B equals 10, C equals -2, and they will solve. Right? But we're not going to spend a lot of time on the inequality just to get them from graphs later on, not yet, not now. Because solution of quadratic inequality is not squarely on your syllabus anymore. All right? That's something of the past. So don't worry about this too much yet. All right. Now we're going to look at the quadratic graph. Let's get jiggy now. So warming up a little bit more now. So we're going to look at the quadratic graph, and there are certain things that we want to pay attention to. All right. Now, remember, it's a function that you use to draw a graph. So I have to introduce a function to you as an example. So the two variables there. And to draw this on a graph, we're going to have to be able to sketch it look at it and sketch it, not plot points and draw it. We're gonna have to sketch it. And let me tell you something before we go any further. If you do an exam question and the question says sketch the graph of this function, for example, and you go and plot points and draw it, you're not gonna get any marks. Because it is easier to plot points and draw rather than to just sketch. Because in order for you to sketch, you have to have certain knowledge, you have to know certain things about the function. You have to be able to look at this function and know certain things. Like, for example, know that it smiles, that a smile shape. Know that it intersects the y-axis at -3, which is what we're going to look at and learn now. So anybody can just plot values and put them on a table and draw the graph. If the question says sketch and you do that, you're getting 0 marks. The student who analyzes a function and tell him that it's smile because the A is positive and tell him that the y-axis intercept is a C value and these things, that student will get all the marks. So even though you take more time to plot the points and do it, you're not going to get any marks. All right, and we have to learn how to sketch it. Before we can do that, we have to be able to look at it and know the properties of it, which we want to look at now. But we're using the graph to help us identify certain things. That's what we're doing the graph for, to help us identify certain things on a positive function. So we're doing this as an example. And to do this, we're going to basically just plot some values. So we're taking a range of values, of x values, from -2 up to 4. And these are the resulting y values. How do we get those y values? We get those y values by taking this x value, for example, and putting it here and here, and work out what it is. Let me do it on the right side for the -2, and size 5. So for example, we have y equals x squared minus 2x minus 3. When the x equals -2, when the x equals -2, what is the y value? We work out the y value by putting the -2, as I said, here and there. So the y value would become -2 squared minus 2 times -2 minus 3. But understand that I replaced the x with -2. But understand that I'm working out what the y value is when the x is -2. Tell me if you understand this before we move on, guys.
So explain it one last time, please.
Right. So this is a function, right, that we're trying to draw the graph for. See it over here on the left side. This is it over here on the left side. And I'm saying I'm going to plot points, x and y values, from x values from -2 up to 4. -2, -1, 0, 1, 2, 3, and 4. And how do I get these y values? I get these y values by putting these x values into the function here and there where the x values are. An example that I'm doing over here now. So that is a function. It means that I take the -2 and I put it here and I put it here. When I do that, see here, this right here is where the x was. So it's now -2 squared. And this right here is where the x was. So it's now -2 times -2. This -2 is this -2. Right? And this x is now -2. And I'm working it out. So the y becomes -2 squared becomes +4. Or -2 times -2 becomes a positive. Negative times negative is positive. So this value becomes 4. Then this is -2 times -2. -2 times -2 again is another +4. Minus times minus is plus, is another +4. And then this -3 remains unchanged, -3. So see that this is 4 plus 4 is 8, and 8 minus 3 is 5. So the y equals 5. And that is why the value occurs, the y value that corresponds, this x value of 2 is a y value of 5. So this now is a pair of values on the graph. X is 2, y is 5. Let's do another example. Let's do an example with the 2 right here. All right, let's do an example with 2. So again, the function is y equals x squared minus 2x minus 2x minus 3. I'm going to see what happens when the x is equal to 2. I have the answer here already now. It is minus 3, but I'm just showing you how I get it. So when x equals 2, the y becomes 2 squared minus 2, and this x becomes at 2. So I'm going to put 2 here, minus this constant is 3, stays 3. So I get y equals 2 squared is 4. Minus 2 times 2 is minus 4. Minus 4. And then this is minus 3 comes back. Minus 3. So this 4 wipe out this 4 comes 0. 4 minus 4 is 0. And so the y is equal to this negative 3. So I get y equals negative 3. So see here, that's why this pair of value. When the x is 2, the y is negative 3. You can understand it now? You want to
Yes,
do another one?
Yes, sir. You
Do
can
another
do
one?
another examples. Yes.
All right, let me do the one with this one right here. So, all right. So I have y equals x squared minus 2x minus 3. And I'm going to see what happens. What is the y value when the x equals 1? I know that the answer is negative 4. I'm just showing you now how I get the negative 4. All right. That's what I'm doing. So I'm going to put the 1 now for the x value. So the y in that case becomes 1 squared minus 2 times 1 minus 3. This becomes 1 squared is just 1. Minus 2 times 1 right here is minus 2. And you have this minus 3 out here. So this minus 2 and this minus 3 is really minus 5. Minus 2 and minus 3 is minus 5. So really then this becomes 1 minus 5. 1 minus 5. And then 1 minus 5 really is negative 4. So y is negative 4. That's why this is negative 4 over here. Good? So all the other values can be worked out that way. So for each of these x values, that's how we work. That's how all these y values are worked out. And so we get these pairs. So that's a pair, that's a pair, that's a pair. So these are like points.
Sir, where does the 0 to 4 come from?
Huh? Huh?
Where does the 0 to 4 come from?
Huh?
Sir, in the equation, sir, in the graph, I only see the negative 2 and I see negative 1, sir. But I don't see the 0 to the 4, sir.
You don't want to get this? You say you don't want to get this one?
No, sir. As in, for the x value, sir, where does 0, 1, 2, 3, 4 come from? You just add those in.
No, man, just random values. Oh, no, yeah, man, just random values. Just a range of values that we're using. We just want to see what the graph is for this range of values. Yeah, it just a set out. I could have go down to negative 3, negative 4, negative 5, negative 6, and I could go up here to the 5, 6, and go further. Okay, and do the whole thing. So we just do for this take a section here. So, because this section, the reason I choose this section right here that I'm doing is sufficient. This section of values is sufficient for me to show you and illustrate to you what I wanted to see on this graph. And you can basically have an idea of what would happen for the rest of the values down here and for the rest of the values up here. Good question you're asking, youngster. Good question. So those values were chosen in a way just that it is sufficient for you to see the characteristics of this function, the main characteristics of this function, what's going to happen with that function. You can get a general idea of what will happen with that function. Very good question you asked. All right? And you understand the answer?
Yes, sir.
Yes, sir.
All right, cool. All right, good.
Sir,
So let's
so
put them on a graph.
they'll tell you how many to put, sir, or you just have to.
They will tell you, yeah, man. They will give you some indication of if they ask you to draw a graph, they'll tell you what values. In fact, most time what they do, they give you the table. Most time what they do is say in CXC, they give you the table and they leave out some of the values. They give you some of the values and they leave out like 3 of the values or 4 of the values. And you have to work out them. You have to work out them 4 values there. You have to work them out, just as I did over here. That's what they normally do. They give you the table and they leave out some of the values and you have to work out the missing values. That's what they normally do in CXC. They'll give you 8 values Give them, if it's 8 values, they might give you 5 of them and you have to work out 3, or they might give you 4 of them and you have to work out 4. All right, that's what they normally do.
Okay,
If they wanted to draw a graph. All right, good. So these are the pairings now. Those are the pairing values. Those are the pairs, like coordinates on a graph. So negative 2, 5 is right here. See there? The negative 1, 0 is this. The 0, negative 3 is this one. The 1, negative 4 is this one. The 2, negative 3 is that one. 3, 0 is here. 4, 5 is that last point right. So I'm going to plot those points on a graph. So to draw the graph, we're not going to worry about scale and so forth. Let's say that is a scale for the graph. And plotting the points. Bam! Those are the points. So let me just show you now. This point up here corresponds to this one, which is negative 2 is the x value, and up to 5 is the y value. See, if this is 4 and this is 6, then right here says the 5, y value of 5. All right, so this one is this point. All right, and then you have negative 5, negative 1, 0. Negative 1, 0 is right here. That's the x value of negative 1 alone. Right? This one is right here. And then 0, negative 3. 0, negative 3 is this point down here. So 0, negative 3. The x value is 0 and the y value is negative 3. The next one is 1, negative 4. 1, negative 4 is this point down here. So see? Look at it, at x value of 1 right here and a y value of negative 4 right there. That point is 1, negative 4. And then this point now, 2, negative 3 is this one. Okay? 2, negative 3, negative 3. This will be negative 3. And then this point is 3, 0. X value of 3, y value of 0, meaning it's on the x-axis. So this point is right here. 3, 0. And then the last point, the 4, 5 point is this one. 4, 5. See? Let's look at it. 4, 5. 4 is the x value out here. And then you come up 5. 5. See? Right here with 5. Correspond to this. 5. So this point is 4, 5. So those are the points. Those are the points that we get when we plot these values for this function. So showing this function on a graph by plotting some of the points, some of the values that you get, or showing it on a graph. And there's certain characteristics and properties that we want to pick up and associate now with the graph. We're going to associate now the graph that we get with the function as it appears there. And that's what we have to learn to do. All right, so let's go. So for what we're going to do now, you join those points with a smooth curve. You join these points with a smooth curve. Join those points with a smooth curve. Those are points, you join them with a smooth curve, bam. That's the curve we're going to get. So that is a quadratic function. So the question that the youngster asks now, if we had more values down here, if we had more values down this way, then it means that this end of the graph, and if you had more values this way, then the two ends of the graph, this end will continue up like that. And this end will continue up like that. Get the picture?
Yes, sir. Sure. So would it provide the graph or do you have to draw it yourself?
No, man, they give you a graph. Man, don't worry about them things there. They give you a graph and all of that, man. Everything gonna report itself, man.
Okay, sir.
Nobody start worry about where you gonna get it, man. Just try to learn the content, man. Just tell you what, just stay within what I'm showing you. But everything that you will need to know, I'm gonna tell you. Believe me. So all those questions we're asking me now about what will come on the exam, we're gonna see them. Why? Because we're gonna do all the past papers together. You're gonna see exactly how the exam questions are set. Whatever I'm showing you now, just try to understand what I'm showing you. But I try to think too far, too fast. Just try to learn the content that we're doing now. All right? Just try to understand what we're doing now. No, we're not start worry about what is coming on the exam paper yet. Just try to understand what I'm trying to show you now. All right. What comes in the exam paper, you'll be well prepared for it and you'll be exposed to everything that is coming on the exam paper. Once you stick to this program, you will be exposed to everything possible that they can put on the exam paper. All right. Because we're going to be first, so we're going to do all the past papers, all of them. We're going to do all of them. We're going to work through all of them. So don't worry yourself. All right. So that's a graph. Now, there are some things now I want to point out to you why the shape of this graph. First thing is that the shape of this graph is a smile shape, and there are certain connections that we can make. Now from this function up here, go back for the red ink. Let's go back for the red ink. From this function up here, what do we have? So the A equals 1, the B equals -2, and the C equals -3. Now in the standard form, these two are particularly important. The A value and the C value, particularly important. All right, in terms of why the graph shape like that and it's like that. All right, and let me tell you how now. Let me tell you how. The first one is that because the A equals 1. A equals 1, 1 is a positive value. It's actually a plus VE means positive. Plus VE means positive. Because the graph, because the A is positive, them say the graph feel good. So it has a smile shape, it smiles. So you see, when the A is positive, the graph will have a smile shape. So the A will always tell you whether the graph will smile or frown. When the A is positive, the graph will smile. When the A is negative in the function, the graph will frown. And when the graph has a smile shape, it comes down to this point, comes down to what we call a minimum point. Watch this now. You must always take the sense of a graph as if you're going from left to right along the graph. So if you think of you going from left to right, I always say left to right because the X values go from left to right this way. And as you go from left to right, the Y values change in a particular way. As you go from left to right, as you take X values from left to right, the Y values change in a particular way. Now, how are the Y values changing initially? How are the Y values changing as you go from left to right? The Y values, if you look at it now, guys, look at the numbers. As the X values go from left to right, look at the Y values. The Y values go down. The Y values go down to this lowest value. And after they go down, then it goes back up. The Y values go down first. And you can see it on the graph. Look, as you go from left to right, the Y values are going down. The Y values going down. Then it come down to this point. And this point is the lowest point that it goes down to. The Y value at this point is -4. This lowest point is called a minimum point. Lowest point, minimum point. It's called a minimum point. And at that minimum point, the Y value is minimum. So the Y value is minimum. Y is minimum.
So, sir, once you find the minimum point, basically you're finished because you can just reciprocate the other one, sir.
No, man, you have other things we can do with the thing, man. We're just going step by step. There are 1 million other things I can ask about this thing. We're just taking it in stages. And I'm telling you that when the graph smiles, it comes down to a minimum point. We have a minimum value. Y has a minimum. Y is minimum. I mean, let's say Y has a minimum value of -4. Let's write it. Or the minimum value of Y is -4. Let's write it like this. Minimum value of Y is -4. When do you get that minimum value of Y? When? See here? The Y is, look up on the graph. The Y is minimum 4 when the X value is 1. When the X is equal to 1. See? Because at this point, this minimum point is a point 1, -4. Corresponding to this point right here, 1, -4. And after it comes down to the minimum, then it goes back up. The graph goes back up from left to right. Oh Lord, so I go that times. I clicked it off. Let's see if I get by the markings. I'm not gonna get by the markings, you know. Sure. Ooh. All right, the recording is there, so you'll see. All right, the recording is there. But what I was saying is that let's click it off accidentally. I don't know what happened. This is the minimum point. Graph goes from left to right. It comes down to this minimum point. This is a minimum point, and that's because the A is positive. The A value is positive. Plus VE means positive because the A value is positive. The A equals 1 with a positive value. The graph has a smile shape. The smile shape graph. It's called a parabolic graph. Parabolic smile shape graph. A quadratic graph is a parabolic graph. It's either smiles or frowns. And so that smile shape, when the A value is positive, comes down to this minimum point. And at that minimum point, the coordinate is 1, -4, where the minimum value is y equal -4 when you get that minimum value, when the x value is 1. Because that is a point. X value is 1 and the y value is -4. That -4 happens to be the lowest y value on the graph. It's called the minimum value of the function. It's called a minimum value. Remember, the y values are the output values, the values that you get out of the function. So the minimum value that you're getting out of this function is -4. That's the lowest value that you get out of the function. I remember I said if you put in more x values this way and more x values this way, then this graph would continue all the way up to infinity and continue all the way up to infinity on this end. And so really and truly, right down here is the lowest value that the graph comes down to. Lowest point that it comes down to, called the minimum point. And you get to that minimum point because the A is positive. There's another thing I want to point out to you now. Let me use a different color. Let me use a black to point that out to you. The other thing I want to point out to you is that the C value, I'm going to use the blue, the orange. Let me see if we can see it with the orange. And the other critical thing that we get from here is that the C value is -3. This C value also is particularly important because that C value corresponds to where the graph intersects the y-axis right here. That point is -3 corresponding to right here, 0, -3. Because when the x is 0, this becomes 0 and this becomes 0. And so the y becomes -3. Right? So that also is another critical value. Another critical value. That's called a y-axis intercept. So the C tells you the y-axis intercept. So this point right here is called a y-axis intercept. So it is y-axis, sometimes it's called the y-intercept. Y-intercept or the y-axis intercept, same thing. So this is the y-intercept. You get the y-axis or the y-intercept from the C value, and see the intercept the y value at -3. Right? So the y-intercept is 0, C. And the C in this case is -3, so it is 0, -3. See, because the C value is -3, which is this point right here. This point right here. So the standard form, two things. The A tells you the shape, and the C tells you the y-axis intercept. The y-axis intercept. And when the shape is a smile shape, it means that the graph comes down to a minimum point. And at that minimum point, the y value is minimum. The lowest y value on the graph is the y value at that point, which occurs when x equals the x value at that point. We're going to look at those values later on. This point is also called the vertex of the function. A lot of things, a lot of information. That's why you have to watch over the video. This point is also called the vertex, or the turning point. It's also called the turning point. That point down here, the minimum point, a very important point. You have to learn and to analyze and find that point. I actually find this point down here by completing the square, which is something that I want us to do today. What time is it now? We're almost going up to 2 hours already. I know the class schedule for 2 hours, but most times it go over 2 hours, most times. I'm taking my time. It's the first class I will take my time. So I might actually do some of this tomorrow. No problem. All right, taking my time. All right, but let me go to the next graph now. So remember, guys, watch over the video and look back at some of these things and let the information stick. I'm gonna do a frown shape graph next now. So that's my shape graph. I'm gonna analyze everything as we go. So a lot of things that I've said a while ago, we're gonna put them into greater perspective as we go. But I just wanted to use some values, actual values, to show you what we get with actual values. We're gonna have to be able to do some of these things without using actual values. That's the point. All right. So let me continue. I'm gonna do that graph now. Notice for this one now. Notice for this one, right off the bat, the x squared term is negative, so the a equals -1. So before I even draw that graph, I know that the graph is gonna have a frown shape. It's gonna go like this. By simply knowing that the x squared term is negative and the a is negative. And the c value is this. C equals 4. So it means that it's gonna cross the y-axis at 4. And know that just by looking at those two values. All right, and let me not circle the x squared. I don't want to circle the x. I just want to circle the 1. It's a -1 right here. Coefficient of x squared. All right, let's get into it. We're going to go through the whole shebang again and plot points and all of that. So we're going to draw the graph for this one. I'm going to see that it comes out to be a frown. So we're going to plot values again. But this time we're starting from -2 and we're going up to 4. What do we do for the first one? We're going -2 to 4 again. All right, we're going -2 to 4. This time again, this one. All right, so bam, we're plotting the values. And the same way how we worked out the values for the first one, the same way we do it with that. Can we do one example from this? So let's say we want to work out, one of it. Let's say I want to work out this one. So that when x is negative, when x is 2, the y is 4, or maybe the 3. Let's do this one. Let's do this one. All right, so the function over here is y equals -x squared plus 2 times x plus 4. I want to see what happens when the x equals 3. What is the output value? What the function give you when x equals 3? What's the function value, the y value? I'm saying it is 1. I'm going to show that it is 1. When x is 3, the function becomes y equals -3 squared plus 2 times 3 plus 4. This 3 squared is 9. So that becomes -9. Because the negative not changing around the square and the 3 alone, not squaring the negative. All right, so this becomes -9. This becomes 6. That becomes +6. Plus, and this is still 4, plus 4. See there, this 6 and this 4 is 10, and the 10 minus 9 is 1. So you see that the y equals 1. See there, that's what I have over there. Y equals 1. All right, let's do another example, some negative values. So we have this pair of values. One pair of value will be 3, 1. Let's do another pair. Let's say I'm working out for this 2. Let's say I'm working on this to see what happens over here. Again, the function is y equals -x squared plus 2x plus 4. I'm going to see what happens when the x equals -2. When x equals -2, the y becomes -2. I have to square the entire -2 now. Plus 2 times -2 plus 4. I'm saying the answer is -4. Let's see. Y equals, I've read about this negative first. Negative. This negative 2 square right here, so now becomes a positive 4. And negative 2 times negative 2 is positive 4. So that becomes a 4. And then this 2 times negative 2 is negative 4. So it's become negative 4. And then plus about this 4. Now what happens now that this negative 4 and this positive 4 wipe out each other. 4 minus 4 is 0. And we are left with y equals negative 4 there. All right. So the y is equal to negative 4. That's what we have here. Y equals negative 4. So we have the point negative 2, negative 4. Guys, you understand that so far?
Yes, sir.
Yes,
All
sir.
right. All right, good. So based on that now, we can plot the points just as we did with the smile graph a while ago. Same thing. Same thing. Those are the points. Those are the pairs of values, right? So this one is this one, and this one is that one, and so on. This last one is this one out here, right? So those are the pairs. So these are the points that we're going to put on a graph now. Did you know? Bam. I put the points on the graph now. See the points there? Let me show you a couple of them now. All right. So this one, negative 2, negative 4 is this point down here. So negative 2 is x value, negative 4 is a y value. Negative 2, negative 4. Then this one, negative 1, 1. See it here? Negative 1, 1. Then the y-axis intercept, as I told you, 0, 4. Bam. See? Because the c value is 4, crosses the y-axis at 4. So the c value is always where it crosses the y-axis. So we know that. And then 1, 5 is this point right here. That looks like the maximum value. See, the highest y value of all these values is the 5 right here. Maximum value. Highest value. Then this point now, 2, 4, is this one. And then this point, 3, 1, is this one. And then the last one, 4, negative 4, is this point down here. 4, negative 4. So those are the points. And then with those points now, all we have to do is draw the graph. So that this graph has a frown shape. I knew it would have a frown shape. How did I know it would have a frown shape? Because the a is negative 1 from this function. So I tell you, getting the a and the b and the c is so important. So when the a is negative, I would say the a right here now is a negative. Minus ve means the word for is the symbol for negative. Minus ve means negative. The a is negative. When the a is negative, the graph will have a frown shape. Don't say the graph of it good. Right. It has a frown shape. You can see it actually has a frown shape. Why does it have a frown shape? It has a frown shape because the y values are increasing first, reaches a maximum, and then the y values start to go down again. That is how it gets this frown shape, because the y values increases to a maximum, and then it starts going down again. That's why it has a frown shape. So this point up here now is called the maximum point. Maximum. When it has a frown shape, the graph has a maximum point. A maximum point. It's still called a vertex, you know. You could say it as a maximum vertex. Still called a vertex. And when it has a maximum point, at that maximum point, you have a maximum y value. See here, this corresponds to the maximum point. You have a maximum y value, a maximum value of the function. Remember, the y values are the function values. The y values are the values that you get out of the function when you put in the x values. So the y values are the function values. So the maximum y value equals 5. That's the maximum y value. When do you get the maximum? When it so happens that you get that maximum when the x is equal to 1. These are things that CXC asks you, like, what is the maximum value? What is the value of x at which the value is maximum? The value of x is 1, and the maximum value is y. Remember, the maximum value is a y value. right? It's referring to the y value. Y value is a function value, the output value. That's what the function is referring to. The function gives you output values. The output values are the y values. And the maximum one on this function is 5. The highest value that this function can give you is 5. And you get to that maximum value of 5 when the x value is 1. Then again, as I said, we have the y-axis intercept, which is the 4 right here, correspond to the c value. So this is because the c is equal to 4. The y-intercept, the y-axis intercept, or what we call the y-intercept. Y-intercept is the point 0c, which happens to be 0, 4, because the c is 4. Is this point right here. So we know from this standard form that the graph crosses the y-axis at 4 without even doing anything. We could have known that. Without doing anything, we could have also known that the graph has a frown shape because the c value, the a value is negative. So we know that it has a frown shape without doing anything. We know that. We know that it has a frown shape. And when it has a frown shape, it has a maximum point. And when it has a maximum point, the y value at that point is the maximum value of the function, the highest y value in the function. Those are the things that we can know. So the standard form tells us the shape, and it also tells us the y-axis intercept, depending on the a value and the c value. So far, so good, guys. When you watch over the video and look back at these things now, and all the information not going to stick in your brain all at once. You have to work at it. So when I post the video, I'm going to send the link to the video in the group. You need to watch it over again. But we're not finished yet, guys. Right? You have to get familiar with some longish classes here. Remember, the exam is 2 hours and 40 minutes. You know, in a sense, you go to class for just 1 hour every day and 1.5 hours every day in preparation for an exam that is 2 hours and 40 minutes. If you go to class every day for 1.5 hours, and then you go into an exam room to do an exam that is 2 hours, 40 minutes, you're going to fall asleep. You're going to lose your concentration after 1.5 hours because that's what your body is used to. So I have to give you classes of the length equivalent to the exam. So you have to bear with it. And remember, you have to do 2.5 hours straight. You can't get no break. And I'm preparing you for a 2 hour 40 minutes exam. And on the same day, you have to do another exam paper, which is 1.5 hours long. So you have to be familiar with that length of time, concentrating and doing maths for that length of time. I know that you're not familiar with this thing, but that's what we're preparing for. It might be difficult today as a first class. It will get easier. So we're not really finished yet. I'm not going to pressure too hard today still. We're not quite 2 hours yet. So I'm going to work a little bit more and do a little bit more. All right, at least introduce the various forms. All right. So far so good. We understand what we have done so far, guys.
Yes,
So
sir.
far so good. Promise me you're gonna look back at the video later and sharpen up on these things, right? Because these are the things. If you know these things, the questions become very easy. All right. I'm gonna look at some questions later. Maybe not today, but maybe we can always spend the first part of the class introducing ourselves, introducing myself, and talking a little bit. That's why, you know, we just reaching here. Normally, we would have finished the content for today already. All right, but don't worry about it. No problem. We catch up tomorrow. All right. So let's continue. Various forms of a quadratic expression. That's what I look at next now. The various forms of a quadratic. And remember, I told you that a quadratic expression can be written in various forms. Each form gives you information that the other forms cannot give you. I'm going to look at it now. Bam. There are 3 main forms in which quadratic expression may be written. 3 main forms. There are multiple forms, but there are 3 main ones for your C6 syllabus. Each form provides information about the quadratic that the other forms cannot. So the standard form gives you some information about the quadratic. Then the vertex form, which is another form we're going to look at shortly, gives you some other information. And then the other form, which is called the factor form,
give you yet some more information. When you put all that information together, you basically know everything about the function. All the critical information you'll know about the function without even plotting points, by just simply rewriting the standard form in two other ways. And you have three forms: the standard form, the vertex form, and the factor form, and the factorized form. All right? That form is called a standard form. And we already know now that the A value tells us the shape. We just did it a while ago. And the C value tells us the y-axis intercept. But remember now, there are other critical information. You can go back and look and tell you, show you quickly, show you some other critical information. I'll show you, there's more critical information and quadratic. I'll mark them and show you. So the standard form here tells us the shape that is frowns in this case because the A negative, and it tells us the y-axis intercept. That's what the standard form tells us. The shape, whether it's a smile or a frown, and it also tells us the y-axis intercept. That's two critical information about a quadratic function, whether it smiles or frowns, and the y-axis intercept. It is the standard form that tells you that. By just looking at the standard form, you can know the shape and you can also know the y-axis intercept. But the other critical point is exactly where is this point. That's called a vertex point, as we said. When you complete the square, you convert the standard form to the vertex form. The vertex form tells you exactly where that point is. And then another critical piece of information is where it intersects the x-axis, these 2 points. These 2 points are called the roots points. They're called the roots. They are called the roots. These 2 points. So you have one root here and another root there. The x values where the graph intersect the x-axis are called the roots. And there's a third form that tells you the roots. And those are the critical things that we want from a function. We want the shape, the vertex, the y-axis intercept, and the roots. Those are the important things. This is a y-intercept. Y-intercept. Let's call it just a y-info now. Y-intercept. Those are the critical information. The shape, whether it's smiles or frowns, the vertex, whether it's a maximum or minimum, and the roots. The shape, y-axis intercept, vertex, and roots. That's what we're basically saying. The standard form tells you the shape and the y-axis intercept. The other point is called a vertex form or the turning point form because it tells you where the vertex is. When you convert from the standard form to the vertex form, you are able to look at the values and know where the turning point is. And then the other form is called the factor form or the root form. When we factorize a quadratic expression and put it in a form similar to this, with the A is a constant out here, then R1 and R2 are the x values on the x-axis, the roots, where the graph intersect the x-axis. And those are the critical, that basically will cover all the critical information, everything that is critical about the function. All right, so 3 forms giving you different information so you can get a total picture. Let's look at some of it in more detail. So the standard form first.
So you can go back quickly, please.
Huh?
So you can go back quickly, please.
Right here?
Yes, sir.
Can I move forward now? Is right here writing it?
Yes, sir, you can move on, sir.
You don't have to write. Remember, it's in the handout, you know. So you don't have to write it. All right. All right. So the standard form now. See here now, bam. This form gives information about the shape. Remember, it's on the A value, you know the shape. Whether it's a minimum shape or a maximum shape. Remember, the minimum shape one is the one that smiles when the A is positive. The maximum shape one is the one that frowns when the A is negative. And it also tells you where the y-axis intercept is because of the C value, 0C. That's what this is saying. Right? So this is when the A is positive. And this is when the A is negative. And this is a C value that I get from right here. And then the A value now tells you this or that one. So the standard form tells you the shape, whether a smile or a frown. And the C in the standard form tells you the y-axis intercept. So that's what you get from the standard form, guys. So see, the A is positive. The graph is going to have a smile shape. And when it has a smile shape, it has a minimum point. It has a minimum point. But just that you don't know where the minimum point is from the standard form. You don't know where it is. But you know the y-axis intercept. So what you know is the y-axis intercept and the shape. That's what you get from the standard form when the A is positive. When the A is negative, bam, you know that it frowns, you know. When the A is negative, you know that it frowns. And you also get the C value from the standard form up here. You know that there's a maximum turning point, you know, but you don't know exactly where the turning point is from the standard form. So that's all you know when the A is negative, that it frowns and it has a maximum point. There's a maximum point, but you don't know where it is. But you know the y-axis intercept from the C value. That's information here that you can get from the standard form. The second form is called the turning point form or the vertex form. And I wanted us to do this form today, convert from standard form to the vertex form. I wanted us to do it today, and I'm running late still. I'll go from the standard form to this form. Now, I write A into x plus h squared plus k. Now, I write this because this is what they mostly set in CXC. They don't set it all the time. They don't set it out like that all the time. And most textbooks will set it out like that, and most teachers will set it out like that. But then still, I have a challenge with this, writing it like this. And I'm going to show you just now why I have a challenge with writing it out like that. I'm going to explain to you. But the vertex form, we tend to use that. Now, this and this is the same thing, you know. This and this really is the same thing, you know. But this one, I use this one because it is a little bit more explicit. This xt, the t simply means turning point, and xt means the turning point x value, the x value at the turning point. And this right yt, again, the t means turning point. And the value right there is going to be the y value at the turning point. So when we convert from the standard form to this vertex form using this method, we know that the value that goes here is the x value at the turning point, and the value that goes here is the y value at the turning point. And it's a matter of how do we calculate this value and this value, because we would have already known the A. So we're going to look at how we calculate the x value to put at the turning point, to put it there, and how we calculate the y value to put it there. And it's a formula to calculate each one. It's a formula for calculating this and a formula for calculating that. That's how we're doing it now. There are other methods to do it, but I'm using the formula method at CSEC. If you do add maths and pure maths with me, you will learn another method. But for now, we're going to use a formula method at the CSEC level. And let's look at the details now. So the xt is the x coordinate at the turning point, or the x value at the turning point. Yt is the y value at the turning point. So you might ask me now, why do I prefer to use this to do it rather than this? I'm going to show you. The reason I do it because CXC don't use this all the time. They tend to change it. They don't use that all the time. All right, so because they don't use that all the time, they are kind of inconsistent with how they represent the vertex form when they ask you in the exam. Then I've decided that no matter what they give you, we're going to use this method. All right, so let me show you, give you some examples. So these are some past paper exam questions. So look at this first one. You see they give us this standard form here, and I want us to write it in this vertex form. See, they give it the H and the K in that one. But look at this here now, 2005 is another example. They give it a standard form again, and I wanted to write it in the vertex form, but this time they put A, B, and C right there. So, see, A, B, and C, not different here, they're not consistent. Look at another year exam. These are exam questions, you know. Again, they give you a standard form, and I wanted to complete the square and write it in the vertex form. They go back to the H and the K. Look down here, 2000, they give you a standard form. They want to write it in the vertex form, but this time again, they put A, B, and C. And I can tell you, sometimes, I think even in recent times, there was a year, or there was an example where the exam for this, for example, they wrote A into X minus H squared plus K. They put minus instead of a plus. Now, this minus can make a big difference. That minus versus this plus up here, it make a big difference if you don't understand specifically what you're doing. All right, let's look at another example still. Look at this one. This year they give a standard form. You want to write a vertex form and then put P and Q. So you see the kind of inconsistent. Look at this one. Give you this and they ask you to write it like that. The same thing. All of them asking you to do the same thing, you know. All these exam questions. But every time they ask it in a different way, set it out differently. And these are just a couple examples. And if I had other questions, other possible questions, you'll see that they keep varying how they express what they want. Right? And as I said, one year, there are occasions where they put minus here, so, and other times they put X plus H squared there, so. And if a teacher teaches you how to just calculate the H and the K, right? Sometimes students mix up what is the H and what is the K. And the way you calculate the H here is different from the way you calculate the H there. Different, but the plus and the minus makes a significant difference. All right, so because of that, regardless of what they tell us or what they tell me to do, then give me this to do, I'm still gonna write it as A into X minus XT squared plus YT. Work out that, and when we get the answer, it will be that way. Anyway, doesn't matter. Then give me this one, don't matter. I'm still gonna use A into X minus XT squared plus YT. Work out makes them YT, when I'm done, I will have that they want me to do. All right, so that's the reason for it, because they are inconsistent with how they present the question with this H and K business. Sometimes they get H and K, sometimes they put plus H, and then other time they put the K in the front, and they put P and Q, some they put A, B, and C. They keep varying and changing. And I don't want the students to get mixed up. And that's why we're sticking to this XT, YT. We know that XT means the X value turning point, YT means the Y value turning point. There's a formula for XT and a formula for YT. You just need to remember this thing, this XT. And it doesn't matter if they put a plus. Doesn't matter if they give you a plus right here. You work it with the minus. And you will know still that the XT is the X value turning point and the YT is the Y value at the turning point. All right? When the square is completed, that's what we're doing here now. We're completing the square. To go from this format, from a standard format, to go from a standard form to this vertex form, use a method called completing the square. So when the square is completed, we are able to identify the coordinates of the maximum and minimum turning point. We also identify the axis of symmetry. So introducing something else now, the axis of symmetry. We're not talking about that just now. Right? Let's introduce the things as we go. So when the A is positive, again, the graph will have a smile shape. And this vertex form that we are using, which is this one. See there, the XT and the YT are the coordinates of the minimum point in this case. And the minimum values, remember, is always the Y value. This is the minimum value, see? Y has a minimum value of YT when the X equals this XT value. These are the things we have to answer. And then we're introducing the axis of symmetry now. So the equation of this axis of symmetry, this vertical line. This vertical line is called the axis of symmetry. Why? It divides the graph into two equal halves. It's like a line of symmetry, like a mirror line between the graph. This line right here. Axis of symmetry, like a mirror line. And this half is a mirror image of this half. Right? There are two halves. Is a mirror image of that half. Such that, for example, this root and this root are equidistant from the line of symmetry. Two roots are the same distance from the line of symmetry. So the graph is symmetrical about that line of symmetry. And the equation of that line of symmetry is always x equals whatever the xt value is. All right, we're going to do a lot of examples and see. So once you know the xt value, you know that the equation of axis of symmetry is x equals that xt value. That's why that xt value is so important. And we also know that the yt value is the y value at the turning point, which is the minimum value of the a is, if the a is positive. If the a is negative, all that will happen is that you now have a frown shape. If the a is negative, it has a frown shape, and we did that when we plot the graph. We saw that when the x squared was negative and the a was negative, the graph produced a frown shape. When it's a frown shape, the vertex point will have the same coordinates, same xt, yt. Just that the yt value now is now going to be a maximum value. The yt value is a maximum value, which occurs when x equals the xt value. You still have a line of symmetry, see there? And the equation is still x equals the xt value. The only thing now is that this one frowns because the a is negative. And that's what they get from the vertex form up here. It tells you where the vertex is and also tells you the axis of symmetry because you know the xt value. All right, second form. Watch over the video, guys. We'll come to the third form, which is the roots form or the factor form. I call it the roots form because it tells you the roots. Remember, the roots are the intersection points with the x-axis, you know, point of intersection with the x-axis. Right? So when you factorize the quadratic expression in this form, make it look like this. The a out here, you have x minus one root and x minus the other root. When you set it out like that, this is one root and this is the other root. And you can factorize it like that. That's a third form that you can write. See there? When the quadratic is factorized, roots are identified. Roots are the x values where the graph cuts the x-axis, like so. So that's it. When a is positive, these are your two roots. See them here? The x value right here and the x value right here are your two roots. And that's all this form can tell you, the two roots. Can't tell you the y-axis intercept, can't tell you the turning point, can only tell you the roots. The a is there, if it's positive, you have a smile. Right? When the a is negative, you have a frown. Again, this factor form up here, when you factorize it, can only tell you the location of the two roots, R1 and R2. Those are the three forms. Let's put them all together now. Let's put them all together. So when you complete the square, when you have the standard form, you complete the square to get this form, which is called a vertex form. You can also go from a standard form by factorization to that form. Three forms. So the standard form, you complete the square, you get the vertex form, which tells you where the vertex is. The factorize to get the roots form, which tells you where the roots are. Let's put them all together on a graph now, color coded. So the blue information you get from the standard form, because the standard form is in blue. The green information you're gonna get from the vertex form, because the vertex form is in green. And the red information we're gonna get from the red form, which is the factor form. Let's look at the graph now. Bam. When the a is greater than 0, the graph will have a smile shape. And the blue form will tell us the y-axis intercept. See it? So all we know from the standard form is that the a is positive, so the graph has a smile shape. And we also know the c value. See, I've marked the c, because we also know the y-axis intercept from the standard form. The information in green is going to tell me where this point is, and also tell me the axis of symmetry. So I can put that information in green. So the vertex form, which is in green, giving me the information that I have on the screen in green. But I understand that so far as we go?
Yes, sir.
And then the form that is in red, which is the factor form right here, is telling me these 2 points, which are the roots. The third form gives me the 2 roots. And now I know all the critical things. Standard form give me 2 pieces of information, the smile and the y-axis intercept. The vertex form give me another critical piece of information. Give me the turning point, the xt and the yt, tells me what the minimum value is, and also gives me the equation of axis of symmetry, which is x equal to xt. And then the third form, which is the roots form, tells me where the roots are. So put them all together, I now have all the critical information for that quadratic function. Let's look if the a was negative. What would that? The a was negative. All that would that means that the graph will frown. And the standard form will tell me the y-axis intercept. Bam! Information in blue, that's all I can get from the form that is in blue. The standard form. All I can get is the shape and the y-axis intercept from the form that is in blue, the standard form. The form that is in green, which is called the turning point form or the vertex form, tells me where the vertex is. The xt and the yt values are the coordinates of that turning point vertex up at the top. And it's a maximum this time. See there? Information in green gives me that green point, information that is shown in green there. The form that is in green gives me the information in green. Also gives me the y-axis intercept. And then the form that is in red gives me the information that I'm going to put on the graph in red, which are the roots. I don't have the roots yet. I factorize, I get the roots now. Put them all together, I now know everything. How that look, guys? How we looking?
Interesting.
Look, all right. All right. So when you rest it a little bit, you watch over the video. All right, watch over the video, guys. I'm gonna post the video later. Watch it over. All right. So anything you miss, you watch it over. We're gonna cement information. I'm gonna practice out all of this and get everything clear in the head. You know that is a lot, but that's what we have to do. But let's continue. So how do we complete the square? To get the complete the square to go from the standard form to the vertex. I want to run through this part quickly, and then we'll spend some more time on it tomorrow. It comes down to a formula. So I just want to just do one example with you before we end the day. All right. I mean, in terms of the actual class, we're not gone 2 hours yet, because we spoke for about half an hour before we started. All right. So completing the square of a quadratic expression. So we'll complete the square to go from the standard form to the vertex form. The vertex form, remember, is a turning point form. All right. So this is a process of converting the quadratic expression from the standard form to the vertex form. That is going from this form over to this form. Remember, we're not using that. All right. I will explain why we're not using that already. This is a standard what they normally put on exam papers and books, but not very consistent with it. So we're going to use something that we're going to remain consistent with. This is it. We are going to be using this instead, x minus xt, because we know that xt means x value at the turning point, and yt means y value at the turning point. It's a formula for calculating xt, formula for calculating yt. If you learn this already in school, some teachers teach you to find h and k, but note that if this sign changes, then the formula that they give you to find the h will be different. Different. You have to pay attention to details, everything important. All right, and all other teachers teach h and k. All right, but I stick to this in my program, but I know can't get mixed up once I stick to this. No mixing up possible. All right, that's why I do it this way. So let's continue. So in this case, x is the variable, and we have a quadratic in x. So this is a quadratic in x. All right, and a, b, c, x, and y, t are all constants. Why? But this becomes a constant. You know? So we're going to calculate it using the a, the b, and the c. And we're also going to calculate that using the a, the b, and the c. And this x is a variable. All right? So they are all constant. And x is a variable. xt and yt may derive in terms of a, b, and c. In other words, you can get a formula for xt and a formula for yt using the a, the b, and the c in the standard form. That's how we started out the class. Identifying the a, the b, and the c correctly. That's how we started the class. We have to get the correct value for a, correct value for b, correct value for c if we're going to calculate the xt value and the yt value using a formula method, which is what we're going to use. If you do advanced with me, I'll show you another method to do it. But for now, we're going to be using a formula method to do it. So deriving xt and yt is the main objective of the process of completing the square. So completing the square really is about calculating the xt value to put here, so, and the yt value to put here, so. Once you calculate those two values, then you write this to that form. Because the a is the same a that is here. So it's really about calculating xt and yt. All right. Now this slide says prove the formula, but I'm not going to bother to prove the formula. I don't need to prove the formula for xt and yt. So this is a method that can prove the formula. I'm not going to bother with that. I don't need it. All right. I'm just going to show you the formula. So that's the formula for xt. Using the a, the b, and the c from the standard form, that's the formula for xt and that's the formula for yt. So let's put on this. These are our first two must know items. So students, to complete the square, you must know this. You must know that formula. You also must know this. So we study them two formula here. It won't be on any formula sheet in the exam. You have to know it in your head. So the formula for calculating xt that goes here, and a formula for calculating yt that goes here. To go from this standard form to that vertex form. All right, as simple as that. So that's two must know items there that you must know. All right. So I'm going to do an example now. One thing left to do is an example. And I'm going to let us sketch a graph. Not only am I going to do an example, I'm going to also sketch a graph and all these things, right? So I can do these two examples, but I want to leave some of these for you to do as homework. But you're really supposed to be doing homework number 1. You're supposed to be doing this question in the handout that I sent in the group. Homework number 1. And those of you who have the handout, you'll see this in the handout. Homework number 1, you're going to be doing. So all these questions up to here. Right? All of these questions up to here. Don't do this one. Yeah, you can do this one. 1 must equals better one. 1, 2, 3, 4, 5, 6, 7 questions. 7 easy questions. And there's another one on the slide. But I'm going to do an example for you now. All right? I'm going to do an example for you. I'm going to work these questions maybe tomorrow. But I want you to try them first. But I'm going to do an example and show you how to use the xt and yt. It's very easy. And I'm also going to sketch a graph. All right, so let me come over. Get a blank screen to do it now. All right, let's do it right here. Okay, guys, we're ready now. I'm going to do an example. I'll show you put all of this together. So I want to complete the square. All right, I want to complete the square. I'm going to do the full shebang, sketch a graph, identify the y-axis, intercept, minimum point, everything. I'm going to do it with this one. 2 of them are going to do this one. And the last one, the first one and the third one we're going to do. All right, we're going to do this one and this one, first and the third. All right, let's go. Instead of calling this g of x, we're just going to call it y, just the same. All right, we're just going to call it y. All right, so we're doing y equals x squared minus 2x minus 3. And when we complete the square, this wants us to complete the square. When we complete the square, we're going to write it in the form y equals a into x minus xt. Don't forget to put the square plus yt. We're not going to bother with the h and the k. We're going to write the xt and the yt. So no matter what them put on exam paper, that's how we're going to do it. To calculate the xt and the yt there, we need to find the a, the b, and the c. So I'm going to write down the a, the b, and the c from up here. From up here, what is the a values, guys? Tell them, what is the a value? What is a equal to from the standard form?
1, sir.
Sir, 1, sir.
What is b equal to?
1, sir.
Yeah, 1 is a. What is b?
Sir, 2.
B is negative 2, sir.
Negative 2.
All right. And what is c?
Negative 3, sir.
Negative 3.
All right, let's write down something we know about this function already. Let's write down some things that we know about this function before we even go into it. Let's write down some things that we can move from a standard form in blue. The A is equal to 1, which is greater than 0, which means positive, which means what? What shape will the graph have?
Smile.
Smile. So the graph will have a smile shape. We know already that the graph will have a smile shape. We're going to sketch a graph now. And since the C value is -3, since the C value is -3, then this tells us that the y-intercept is 0 what? 0, -3. The y-intercept is always 0, C now. Right? The y-intercept is 0, C, and C happens to be -3. So we know that the graph of this function will smile and will cross the y-axis at -3. That's all we know so far. Because we get that from the standard form. So we're going to complete the square now and go down to the vertex form. And then when we get to the vertex form, we'll also know the turning point, and then we'll be able to sketch a graph. Sketch it, all right, from that information. So let's calculate the xt and the yt now. Ready? So the xt value for here. So we can say now, the xt value is minus b over 2a. See, that's what we have on the slide on the left side, minus b over 2a. All right, watch this now. This is equal to minus, this minus is this one, right at first. But the b is -2, so it's minus -2. See that? Minus -2. So I'm going to erase back this and that. So it's minus -2. So you see it's minus b. So it's minus -2, because the b is actually -2 right there. Divided by 2 times the a value. 2 times 1. The a value is 1. This works out to minus give me a +2. And 2 times 1 is 2. I use an easy values now, I'll get 1. I'm giving an example with easy values. So I say my xt is 1. So I mean that this 1 value is coming right here where the x is. Where the xt is. Simple as that. And I'm the yt values now. Yt value now. And there's another way to calculate yt, but I'm using the formula method for now. I'll show the other method later on where you master the formula method first. Is 4ac minus b squared divided by 4a. That's a formula. You have to know that formula. 4ac minus b squared divided by 4a. I have the a there. You have the a, the b, and the c up here. Same values we're using from the standard form. Equals 4 times the a value is 1 times the c value is -3 minus, that's this minus. We're not squaring it. We are only squaring the b, where the b is -2. So we're squaring -2 all over 4 times a. The a value is 1. But understand that? But understand that?
I can re-explain the YT portion.
Huh?
So I was asking if you can re-explain that last part you said.
Write it again. Let me write it again. Let's write it again. So plugging in these values into this formula down here. So how we're doing? Substituting values in that formula. Ready again. So it becomes 4 times a. 4 times a. A value is 1. So it becomes 4 times 1. Times c. C is -3. C is -3. So for the c, you put -3. This is 4ac. Then we have minus b squared. But the b is this, -2. So for the b, we're going to put -2 and put on the square. And this now is the b. All over 4a. And the a is this one right here. 4 times 1. Better? Feeling any better?
Yes, sir.
And then we just work down the values now. Work it down. Work out the whole numerator first before you divide, right? So work out the numerator. So the yt, this yt is equal to, this becomes -12. because 4 times 1 is 4. 4 times negative 3 is negative 12. Negative 12. Minus, that this minus comes back here. And not changing that minus, it's not squaring. Only squaring the b. That comes back as a minus. And then this negative 2 squared now becomes a 4. So I'm going to put a 4 right here for that. Negative 2 squared is a 4. And then you're dividing that now by 4 times 1. 4 times 1 under here says 4. 4. All right, what did I erase? This is just a 4. This becomes negative 16 over 4. Let's write it out. This becomes negative 16. Negative 16 over 4, which then is negative 4. 16 over 4 is 4, but it's negative. So this negative 4 coming right here for the YT value. Right? So the plus YT is negative 4. So in order to have the XT value and the YT value, I can go ahead now and I can write this vertex form down here. So that vertex form becomes Y equals the A is 1. Since it's 1, I can put that down, but let's put it 1 bracket X minus, see there, X minus the XT value is 1. So X minus 1. Don't forget to put on the square. Put on the square. The plus YT is negative 4. Plus YT is negative 4. Remember, YT by itself. YT by itself is same as a plus YT, you know. So we have a plus YT. We're gonna replace it with a negative 4. So the plus YT is negative 4. So I'm gonna write negative 4. And this is it. I've completed the square. That's it. That's a vertex form. By just calculating XT and YT and putting the values there. Now from this XT and YT now. Everybody understand that so far? Everybody good so far with that?
Yes.
All right.
Yes,
Don't worry.
yes, sir.
I do an exam and get it clear. The more we do, the clearer it will get. Don't worry yourself. So from this vertex form now, you know that is a minimum point because it smiled to the minimum point, don't it? So we can move it up here. So it's a minimum point. That's why I write the word min. Because it smiles, it comes down to a minimum point. Once it smiles, it comes down first, a minimum point. So we know that it has a minimum. So we know that XT and YT are the minimum point. So the minimum is XT, YT. That minimum XT, YT happens to be XT is 1 and YT is negative 4. So the minimum point is that. 1 negative 4, that's what the minimum point is. So we know say it smile. We know say cut the y-axis at 0, negative 3. And we know say it have a minimum turning point at 1, negative 4. A minimum turning point at 1, negative 4. Then we also have the axis of symmetry. What was the axis of symmetry again? X equals XT value. So we can write that. Axis of symmetry is X equals whatever the XT value is, which is 1. See there? The axis of symmetry is really X equals 1. This is the equation of axis of symmetry. X equals 1. And with all that information, we can sketch a graph. We'll copy them and put them down here and sketch it. I'm going to take this first, copy that down. I'm going to sketch it and I'm going to put them down here. So we have all of them in front of us. So we have this. We also have this. We also have this axis of symmetry. Kind of big, but this is axis of symmetry. Let's write it. Axis of symmetry. Axis of symmetry. I'm going to copy this down as well. Put it over here. That's all the information, guys. You can sketch a graph from that. Right? that and that. 3 pieces of information. So we can sketch a graph using that. All right, let's go through it now. Sketching the graph. It's a sketch. You don't have to be accurate. You're not going to plot any points on it. It's just a sketch. So not like a graph that we drew from scratch. This is just a sketch. The sketch must have the right shape and the critical point. Remember, we're not talking about the roots now. We're leaving out the roots. Because to get the roots, we're going to go to the factor form. But we're not going to deal with the roots. No, we're just going to deal with the y-axis intercept, the shape, and the vertex, the turning point. All right, so watch this now. Y-axis, x-axis. All right, so let's look at the sequence of questions that you do for yourself now to draw this properly. So now there's gonna have a smile shape, right? The first question is that a smile shape, where does it turn? It turn over here, so, turn over here, so, turn over here, so, or turn over here, so. This is the turning point. Where would that point be? Here, 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 or there? Somebody tell me.
Sir, bottom right, sir.
Bottom right. Very good. Right? A positive x value and a negative y value. See there? Positive x value is this way, negative y value is down here. So we know that the turning point is somewhere down here. We know that. So we know that. All right. So we know that it turns somewhere down here. It has a smile shape and down here turns somewhere. Next thing is, where does it cut the y-axis at 0, -3? 0, -3 somewhere up here, or is it somewhere down here? Which one? 0,
Sir, down the
3.
bottom, sir.
So we know that it good. So we know that it crosses the y-axis somewhere down here. So we just need to draw a smile that turns over here, so turns here, so and cross here, so easy. Any smile that turns down here and crosses somewhere down here. It's just a sketch we're doing. So I'm just gonna draw it randomly. And this is it, see there? Let's draw it again. That's it. That's my sketch. Don't have to be accurate. Some person sketch might be a little bit not well. It have to come down here. Narrow like that. Some person one might be wider. Like that. It doesn't matter. See, just one who said smiles. Turn somewhere down here and cross somewhere down here. And when I draw that now, I just need to put this as my minimum point. And write.
Wait, so say you don't have to line up the graph?
No, it's not a graph we do, it's just doing a sketch. Don't have to be accurate, just a sketch.
Oh,
The
right.
critical thing, just a sketch. So it's 1, -4, and my y-axis intercept right here is 0, -3. That's all I know for now. I don't know my roots yet. I don't know these yet. I can't put them in yet. Today we're not focusing on roots. Then I can put in my y-axis intercept, my axis of symmetry. It's a vertical line passed through the turning point, like this. That's my axis of symmetry. Axis of symmetry. And the equation is this: x equals 1. Because the x value right here is 1. So x equals 1 is the equation of this line. This line has this equation, x equals 1. And that's my sketch. And you can label it up. Sketch of y equals x squared minus 2x minus 3. See? So the function that we started with. X squared minus 2x minus 3. Sketch of it. That's a sketch of it. Do it in the exam, you get a full marks for that sketch. And I can show that those are the things that they ask an exam paper actually. So we look at the first example on the homework. You'll see that those are the things that they ask you. You're going to spray now? Yeah, man, just give me a minute. That's one finish. Yeah, man. Yeah, man, give me a minute. That's one finish. Yeah. Right? So if I look at this question, you see that these are the things that they ask you. So the first part is to write it in this from this to this form, but instead of using this, we will say a into x minus xt squared plus yt. That is all. And what I'm asking for now, they ask for the minimum value. Minimum value is just the YT value, you know. The value of X at the minimum occurs. That is just the XT value. Then you see there, there's a sketch graph showing the minimum point, the y-axis intercept. Now, them say the value of X will intersect the x-axis. We're not doing this yet, so we won't include this part yet. You see, those are the things that we just did a while ago. That is with another example. Right? So if we look back at the example that we had doing, where is it? It's here. Right? And it asks us for the minimum value. The minimum value is the YT value. Right? So we could say the minimum value of Y is the Y value at the turning point down here. That's the lowest Y value in the graph. Is -4, which occurs when X equals this value. So the Y value is this, when the X value is that 1. That's the same question that was asked us a while ago. That's the example. All right, good and easy. I'm going to fly through the front one down here, quick and fast, and then we can call it a day. Tomorrow we're going to do some more examples. I want you to redo the example that I did. Yeah?
What time class start tomorrow, Shay?
Scheduled for 5, but I might actually start it at 3 because nobody not going to face-to-face school.
When, sir?
I will start it at 3 o'clock Jamaica time, 4 o'clock Trinidad time, because nobody going to school, nobody going to face-to-face school.
No, sir, online, sir.
Right. So since everybody will be online, I might have started at 3 o'clock instead. All right. But I send a message out into the group to confirm. I think that's what we'll do. Start it at 3.
Sir,
Everybody
sir, I was wondering if we could have started at 3:30, sir, because like school finished at 2:35, sir. So I want like a little time to
all right, so maybe
cool off,
3,
sir.
right, so maybe 3:34. We start at 3:30. We'll decide. A little bit earlier. So that people don't have to be there waiting for 5 o'clock class. But we're not everybody at home. We're doing online. And nobody going to school. The person who are going to school now and have to venture home and stuff, then we'll start at 5. But we might have started earlier. All right? All right? Okay.
Yes, sir.
I'm gonna start speaking on. Oh, all right. I'm going. All right, guys. I have to come out the room because I'm gonna do an operation. So I start by the class tomorrow with this example. Okay. So for now, I still wanted to try this example. Try this example. Watch over the video. Right? Try this example. Try the one that do over the one that I just did. Do over this one that I just did, this first one. Do over this one that I just did. Try this one and maybe the other 2. All right. And I want you in your handout. If you don't have the handout, you can screenshot this page. I want you to do this. Screenshot that page, and I want you to try those questions until tomorrow. I'm gonna work a lot of these questions tomorrow, but you don't have to do down here yet. You don't have to do down here yet. All right. But I wanted to try this. Try that one. Number 2. All right, let's try them. It don't matter if you get it right or wrong, you learn from your mistakes. I'm gonna end the session now because I have to leave the room because I'm gonna do an operation here. All right. It's a good time for the class anyway. So we'll pick up back where we left off tomorrow. Okay, guys?
Yes, sir.
Yes, sir.
All right then. All right. So see you all tomorrow. It was a good first class. I like the participation. I hope more persons will jump in, participate more. All right. I want everybody to participate more. So see you guys tomorrow. Remember, watch over the video. Very important.
Yes, sir. Tomorrow.
All right, so
Okay.
bye guys. All right, bye. I'm gonna end the session now. Bye everybody. All right, bye.
Bye, sir.
Bye bye.
Bye, sir.
All right.